Yeah, good evening, everyone. You are welcome to tonight's class. Can you hear my voice, please?
Yes,
We
sir.
can
We can,
hear you.
sir, we can hear the sound of your voice, sir.
Okay, thank you. Thank you. So, you are welcome to tonight's class, and this is the final topic under the EMS 727 basic statistical procedure, in which we've treated descriptive statistics. Under the descriptive statistics, so we treated the graphical part of descriptive statistics and the calculating aspect of descriptive statistics. So under the graphical part, we made mention of the bar chart, the histogram, and the box plots. And then under the calculating part of descriptive statistics, we made mention of the measure of location, which we also call the measure of central tendency, and then we also made mention of measure of dispersion. So under the measure of location, we checked mean, media, and the mode. And then under the measure of dispersion, we checked the range, we checked the variance, we checked the standard deviation, we check the quartile, and then we also check coefficient of variation. So after that, we move down to inferential statistics. So under the inferential statistics, we check the estimation and the test of hypothesis. So under the estimation, we check the point estimate and the interval estimate. Well, under the testing of hypothesis, we check the Z test, we check the T test, we check the F test, we check the chi-square test, and then we stated the criteria for choosing tests. Or if you see this particular question, what particular test are you going to choose? Then we also check the three type of T. We check one sample T test. We check two sample. We check dependent or peer T test, and we also check independent two sample T test, in which we solve question from the past question as example. Also, we move down to the probability, in which we check the definition of probability, we check the type of probability, then we check the we check the how they make use of the probability. Also, we also move down to probability distribution function. Under that, we check the Bernoulli distribution, we check the binomial distribution, and we check the Poisson distribution, which are also called a discrete distribution, because under the probability distribution function we have a discrete and then we have continuous. So under the discrete we check those one that I've mentioned. Then other than the continuous, we have different type of continuous under the probability distribution function, but the one that we check, which it is useful for us here at EMS 727, is the normal distribution. So we check the normal distribution. We also stated the properties of normal distribution, and we solve question on under normal distribution, in which we use standardized normal distribution. And when you're talking about standardized normal distribution, it means that the mean is equals to 0 and the standard deviation is equals to 1, or the mean is equals to 0 and then the variance is equals to 1, because if you take the square root of 1, it's still going to give you 1. So under that, we've checked the probability. Now the last part of EMS 727 is what we call the correlation and regression. Correlation and regression, that is what we are going to be checking tonight, the correlation and the regression. Are we still together, please?
Yes, sir. We are together,
Yes,
sir.
sir.
Okay, so let's move to the business of the day. So
Good evening, sir.
tonight, yeah, good evening. So
I am
tonight,
so sorry for interrupting. Please, I heard you said something about taking us box plots. I just wanted to confirm. I'm not sure if we actually treated that in descriptive statistics.
Yes, we've talked
Thank
about the box plots in descriptive statistics, in which I may mention that we normally use box plots to check the distribution of the data. So box plot will
in
divide your
this area.
data. You said?
I said in okay, okay, thank you.
All right. So correlation and regression. Uh, we're going to be taking it one after the other, and then we have a long way to go tonight, but God will help us as we go. Now, correlation. Aside from this definition that I have, anytime you have a numeric value or a numeric data or a numeric variable, which is also called a continuous variable, and you want to check the relationship between them, or you want to check the association between them, or you want to measure of the strength of association or the strength of relationship between the two variables. Remember, the two variable must be what? Must be a continuous variable. If you recall from our chi-square, if we want to check the association between the variable must be what? Must be a categorical. Now, if the variable is now continuous or numeric or quantitative now, we normally use correlation to check the strength of the association. We also use correlation to check the direction in which the data are moving. So let's quickly check the definition that I have here. Correlation is a statistical measure that indicate the strength and direction of the relationship between two variables. That two variable must be a continuous variable. It is very, very important. It is essential in data analysis as it helps determine if and how strong pair of variable are related. I've made mention this the other time. When you are talking about the correlation, you want to check the association between two quantitative variables. You want to check the agreement. You want to check their strength of association. Now, correlation quantify the degree to which two variables move in relation to each other. Now, in correlation, it's either we have a positive or you have a negative. You can have a positive, you can have a negative. That is, when your value is less than 0, you are going to have a negative correlation, and when your value is greater than 0, you are going to have a positive correlation. But in a situation whereby you have your correlation value to be equals to 0, that means that there is no relationship, there is no association between the two variables that you are checking. So we have a positive correlation. Positive correlation means that as one variable increases, the other also tend to increase. That is, let's say for instance, as your age, if the age and height, they have a positive correlation, that means that as you are getting older, then your height is also increasing. So that is mean by the positive correlation. Let's say for instance, as the diet taking is increasing, maybe the level of sugar also increasing. So that means that the diet and the level of sugar, they are positive correlated. Now, when we're talking about the negative correlation simply means that as the one variable is increasing, the other one is decreasing. As one variable is going up, the other one is going down. Then the last part that we have is what we call a zero correlation. Anytime you have a zero correlation, this implies that there is no relationship between the two variable. Now let's move further. Now, correlation value. Correlation take its value from -1 less than or equals to r less than or equals to 1. -1 less than or equals to r less than or equals to 1. So anytime you are having a -1, that is what we call a perfect negative correlation. Anytime you are having your r to be equals to -1, that is what we call a perfect negative correlation. And anytime you have your R to be equals to 1, we have what we call a positive perfect correlation. Anytime you have your R to be equals to 1, that is what we call a positive perfect correlation. But we also have a range of value for correlation. Let's say, for instance, if you have your correlation value starting from 0.75 up to 0.99, it is called a what? A strong positive correlation. Let me take that again. If you have your value from 0.71 to 0.99, it is called a what? A strong positive correlation. The same thing goes for the negative. When you have your value from minus 0.75 to minus 0.99, it is called a strong negative correlation. Now, let's say, for instance, you have your value in between, let's say, for instance, from 0.50 to 0.74. We normally consider that as strong what? Strong correlation. Strong correlation from 0.5 to 0.74. We normally consider that as what? As strong correlation. Let's take it back to the negative. If you have minus 0.5 to minus 0.74, we call that one to a what? A strong negative correlation, but not very strong. Note that it is not what? It is not very strong. But any value you are having from 0.49 down, from 0.49 down, that's what we call a weak positive correlation. 0.49 down, it means a weak positive correlation. Then anytime you are having minus 0.49 down, that is what we call a what? A weak negative correlation. So in case if you are calculating your correlation and they ask you to interpret your correlation based on the value, you should be able to interpret your what? Your correlation. So under the correlation, we have a Pearson, we have types of correlation. We have what we call a Pearson correlation. A Pearson correlation measures the what? The linear relationship between the two variables that are continuous. We normally use a what? We normally use a Pearson correlation. Now we have a Spearman correlation. Please listen to this. Anytime you are using a Spearman correlation, normally Spearman correlation is part of non-parametrics. We normally use it when your variable, or sorry, when your data is not normally distributed. We normally use what? We normally use Spearman correlation. What we normally do there is that we rank those variables, we rank those figures, and then from there we make decision. We are going to, we are going to see it in example when we move further. Then the last one we have under correlation is what we call the Kendall correlation. We call them Kendall correlation. This one is beyond 727, but in case maybe you are carrying out your research, or you are carrying out your project, and you now discover that your data is not normally distributed. That does not mean that you dispute that data. When you discover that it does not follow the assumption of normality, that does not mean that you are going to discard the data. There is another way in which we can what? We can still bring out the information from the data. There's another way in which we can bring out the useful information from the data. So that other way is what we call a non-parametrics. Any value, that any variables or any data that does not what? Follow the assumption of normality, it is what we all is not what? Not parametrics. So now in a non-parametric, we normally use a what? A Kendall style correlation. A non-parametric data measure the strength of association using rank. Kendall style correlation normally use what? Normally use rank. So this number 3 is beyond the scope of what? Of 727. But nonetheless, I put it there so that anytime maybe you are carrying out your research and you come across this, you should be able to relate, or maybe during your research when you are downloading journal to strengthen your literature review, or to strengthen your background of that research, you may come across this value called Kendall style correlation, so that it will not be strange, it will not be new to you that, oh, somewhere I've heard about what? A Kendall style correlation. So let's move further, please. Now,
Please,
under the case,
I can't see your screen, sir.
there is my screen is on. Please check your network. My screen is on. Can you see my screen?
Yes, I
Yes.
would. Yes, I would. Can see your screen.
Hello,
Okay,
sir.
thank you. Okay.
Hello, sir. Please, sir, I don't know. I can see your screen, but the slides are. I think it would be better if the fonts are colored on a plain background or white background. It's kind of not it's not convenient reading from the
Can you
way
see
the
my screen?
slides are. I can see your screen, sir, but I mean, if it would it would have been better if the slide is not
You
dark,
can
if
zoom
the
it.
background.
Just zoom your phone. It will be
Excuse me, sir.
more visible.
The font is okay. Please kindly zoom your screen. You will see it very well. Okay. Let's fire down, please. No time.
Or you can also rotate
Good
it.
evening, sir.
You can rotate your phone. So if you rotate it, it will be wider. That works actually.
Okay, let's continue. The fonts normally are supposed to use 16, but it's because of this class I changed it to 23. So the font is okay because I'm also monitoring it as I'm presenting. Maybe you should increase the brightness of your phone, or you should rotate your phone, or you should zoom your phone. One of the three will work. Sorry for that. I will have used colored normally. So sorry for that. So let's continue. Now we have correlation, we have Pearson correlation formula, which is we have R is equals to we have summation X minus X bar into Y minus Y bar. By now, all this X bar, Y bar should not be new. By now, it should not be new. The X bar is simply means the mean, which means that you are going to add all the X's that you have together divided by the number of observation. That is the X bar. If it is Y bar simply means that you add all the Y's that you have together divided by the number of what? The number of observation. So that is X bar and the Y bar. Then the XI that you are seeing there is just the number, is just what? It's just those data that you have. That is the meaning of what? The XI, those data that you what? That you have. Now, divided by the square root of summation X bar my XI minus X bar square times Y I minus Y bar square, supposed to be Y bar square, YI minus Y bar square. So by the time you do that, we are going to have this correlation coefficient, which is equation 1. If you look at the equation 2, I open this bracket of equation 1 so that I can have another equation, which is equation 2, in which you can relate any one of the two, it is correct. Now, if I expand this, the equation 1 becomes n summation xy. That is, you are going to multiply the x and y, then you will add them together. That is the meaning of summation xy. Then multiply by what? Multiply by the n. N is the number of observation that you have. Then minus the summation x. Summation x means that add all the x's that you have together, multiply by what? Add all the.
Lisa, we can't see your screen.
Kindly check your network. We can see the screen, man.
We can see the screen.
Okay, thank you. So by the time you do the multiplication, you are going to multiply summation x multiplied by the summation y, then divided by the square root. Please note this. This is the square root. This is the square root because most question that I sent to that group that people solved, they didn't put the square root when they are calculating their correlation. There must be square roots there. So the square roots, then we have n. N is the number of observation, then summation x squared. That is the observation x that you have. You are going to square them one by one. You will square the first one, you will square the second one, you square the third one up to the last one. So by the time you do the square, then you now add them together. That is what we call the summation x squared. Then minus, remember that you've gotten your summation x from this numerator. Just square it. That's what I mean by summation x all squared. There is difference between summation x squared and summation x all squared. Summation x all squared simply means that you are going to add all the x's together first. Then after adding them together, then you will now square it. That is what we call the summation x all squared. But the summation x squared simply means that you are going to square the x's first. After squaring them, then you will now add them together. That is what we call the summation x squared. Now, the same thing go for y. We have what? We have n into what? Summation y squared minus supposed to be summation y all square. N into summation what? So n into summation y square minus summation y all square. Any question before we continue? Any
Hello,
question,
sir.
please? Oh,
Thank you very
yes,
much,
sir.
sir. Thank you, sir. This second formula for the correlation, is it the first one
Yes,
you
sir.
expanded?
Yes, sir. When you expand
It-
the first one here, the first one, the equation one, you are going to get the
Equation
equation two.
one, yes, sir. But
Yes.
sir, in the equation one, there is no n in the
Yes.
equation one.
Okay,
That's
good. Yeah,
exactly what I noticed too.
good. There is no n in equation one. But remember that what is x bar? X bar is summation x over n. X bar is summation what? Some x bar is summation x over n. So now, by the time I'm bringing that n out, the summation, I'm going to left with what? With summation x. I don't know maybe what I'm trying to say. The y bar is what? Summation what? Summation y over what? Over n. I just don't
Okay.
want to bother you with the equation. It's like a 5 or 6
Okay,
steps
okay, sir. So
before
we
we get.
understand that. That's the mean. That's the mean, sir.
That's the main. Yes,
Yes.
that's the main.
Summation of all the observations all over the
Yes.
frequency or number. Okay. Thank you,
Yes.
sir.
So if you multiply this now, if you multiply this numerator now, by the time you multiply it by 1 over n, if you multiply this by 1 over n, this one will cancel out. We're going to have summation x. When this one want to come in, I'm going to have a summation what? Summation x over n multiplied by summation what? Summation y over n. So by the time I'm factorizing the summation out, I'm going to get back to this, which is summation I minus x bar, then summation y, sorry, yi minus y bar. So the expansion of this that give the equation 2. Can we move on, please?
Yes, sir. We can, sir. Thank you,
All
sir.
right. Thank
See,
you.
sir,
Thank you.
sir,
Thank you, sir.
I have a question. I have a question.
Okay.
Hello, sir.
I'm
The
with you.
equation, the denominator, is it not supposed to be summation y all squared? For the second part of the denominator,
Which one?
like I'm seeing
Yes.
n summation y squared minus
Yes.
summation y all squared.
Yes. Yes. I made mention of that here we have summation y all square. When you're typing on this
Okay,
equation, you got the so I'm
okay,
going to correct
okay,
that
sir.
before we send it to the group.
The entire
Also,
denominator
also,
has square roots. Okay,
yes, yeah, that's the square root that you are seeing here. That's the
okay,
square
sir.
root that you are seeing here. If you also check this first equation, it's supposed to be yi minus y bar. Did you get it?
Okay.
So yeah, for this equation one, it's supposed to be what? Yi minus y bar square, not x bar. So I'm going to correct this. This is going to be y bar, and this one is going to have summation y square. Do we get that, please?
Yes, sir. Thank you, sir.
Okay, good.
Good evening, sir.
Let's look.
I have another
Yeah, good
question,
evening.
sir. Sir,
Yes,
that
ma'am.
N, say the number of observations, or you have to find the mean first.
The what, ma'am?
The N,
The end.
the N that you
Yes.
brought out, is it number of observation
Okay.
or the mean?
Is the number of observation.
Okay,
Is
thank
the
you, sir.
number of observation. Yes, ma'am.
Thank you, sir.
All right. Thank you, ma'am. So now we have the Spearman rank. We've talked about the Pearson. So any of these formula, if you use them, you are good to go. So now we move to the Spearman rank correlation. Spearman rank correlation coefficient, often called a Spearman rule. Remember that when you're talking about the Pearson, we normally use R. But when you're talking about the Spearman always use this sign. We call this sign rule. Rule is a non-parametrics. I mentioned that the other time. Spearman rank is a non-parametrics. It's a non-parametrics measure of the strength and direction of association between two ranked variables. That is, once you discover that your data does not follow a normality assumption, or your data mostly we normally use Spearman rank when your data does not follow assumption, or if the question stated otherwise that this particular question use Spearman. And please note this: if you are given a correlation question to solve, and if they did not mention any method that you should use, I will advise you should use a Pearson correlation. I will advise you to use a what? A Pearson correlation. If they did not state any method, whether you should use Spearman rank or you should use a Pearson, it is advisable to use a what? To use a Pearson correlation. Unlike the Pearson correlation, which measure the linear relationship, Spearman correlation assesses monotonic relationship. Monotonic relationship simply means that is it increasing or decreasing. Monotonic relationship, which means that it measures how well the relationship between two variables can describe using a monotonic function, whereas the variable either increase or decrease together. That is what they mean by monotonic. If it is monotonic increasing, that means that the two variables are moving up together. If it is monotonic decreasing, that means that the two variables are what? Are moving down together. Now, key point of Spearman correlation. The range. The Spearman correlation range from -1 to 1. Like the same thing with the Pearson correlation. They take their value from -1 to 1. When your rho, which is the what, which is the value of the what of the Spearman correlation, is equals to 1, we have a perfect positive monotonic relationship. As one variable increases, the other also increases. So now if you have for your rho to be -1, it means that the perfect negative monotonic relationship. So that means that if you are interpreting, if it is Spearman rank, the what? The negative monotonic increasing is very, very important. If it is Pearson correlation, that is what? That is perfect positive relationship. Perfect positive relationship. Because if I'm saying perfect positive relationship for Spearman rank, monotonic is the one that differentiates between the Spearman and then the what? The interpretation of the Spearman and then the interpretation of the what? Of the Pearson. In Pearson, we don't use monotonic, but in Spearman, we normally use what? A monotonic. Now let's continue, please. Now we have the formula for Spearman. Remember that I gave a formula for Pearson. Then also we have the formula for Spearman. The Spearman correlation coefficient is calculated with the following formula. We have the rho, which is equals to 1 minus 6 summation di square over n into bracket n square minus 1. Please note that if you are treating this, you first of all treat summation 6 summation d square over n minus n square, n into bracket n square minus 1 first. The value that you now have here, you will now subtract it from 1. Not that you are going to subtract the numerator from 1. No, you are going to treat this one first before you now subtract it from 1. It is very, very important. Now, what is DI? DI is the difference between the rank of corresponding values of X and Y. So that is the meaning of what? Of the D. We are going to, when we start solving question now, we are going to understand better. Then N is the number of paired rank, that is X and Y. If you are pairing the X and Y together, so that means that the number of observation. So if you are pairing the X and Y together, the difference will be the rank of X minus the rank of Y. Like if you recall from our normal t-test, the dependent t-test, that we normally find our D after minus before. But in the case of the Spearman, if you want to find your D there, it's going to be the rank of the X minus the rank of the Y. The rank of the X minus the rank of the Y. The example so that all what we have been saying will not look like an abstract. It is real. Let us test it with data. But before we do that, do we have any question? Floor is open. If you have a question, please ask before we go to the first example.
Hello, sir.
Yes,
What if you
ma'am.
didn't use What if you didn't use the Spearman rank, you use the other formula? Is it still okay?
Okay. If the question did not stated otherwise, please use Spearman. Sorry, use Pearson. If the question is not stated, use Pearson. But if the question in your question, if they stated there that use Spearman, please use Spearman. Because I'm going to show you the next example. I'm going to show you that we use what? Pearson. Although I don't think they mentioned the type of correlation we should use. But I use Pearson. But if you want to use Spearman for that question, you will discover that we are going to get 0. which is not the same thing with what? With the piercing. So if the question is not stated otherwise, please and please use piercing. Any other question, please?
Thank you, sir.
All right, thank you. So let's look at this first example. If we look at this example,
Please, sir, your slide is not moving.
still with the example one. Can you say example one?
No, I'm still seeing correlation and regression, Spearman rank correlation.
Yes, Spearman rank
That is where
correlation
we are.
coefficient.
Key
That
points
is
of Spearman correlation.
That should be your network.
Not showing.
check your network. We are now
That should be your network, please.
example one now. Example one.
All right, thank you.
Example one now. Adapted from 2021, 2022, 5B. The table below show the data on age and height of soya beans plant, because that particular question was scam scanner, so I could not even really see what they wrote there. So soya beans plant in a field. So now we have the X. X here is telling us the age of the soya beans. They planted it. The first year, this is year one. They checked the height. The height of that soya beans was what? Was 5. At the end of the year two, it has increased to what? To 3, to 13 rather. At the end of year three we have 16. Year 4 we have 23. Year 5 33. Year 6 we have 38, and then year 7 we have what? We have 40. Can you see my slide now? The person that asked that the slide is not moving, are we on the same
Yes,
page?
sir. Yes, sir. It's moving. I rejoined, so yes, it's moving now.
Okay.
Yes, we're on the same
Okay.
page. Thank you.
Thank you. Now let us now look at this. My X, the age here is X. That's why I'm putting X. And then the height here is Y. If you look at this, my first row here, the first row is the X row. Sorry, the first column is the X column, and then the second column is the Y column. Now, the year 1, 2, 3, 4, 5, up to 7. If I do the summation of this, if I add them together, I'm going to have what? 29. 1 plus 2 plus 3 plus 4 plus 5 plus 6 and then plus 7. I'm going to have this. Now, the same thing goes for Y. If I add everything here together, I'm going to have a 168. Now, the next thing is I want to find the X square. That is, I'm going to square each of X's. Please note, those people calculating, if I ask you to calculate the variance, that we normally use summation X square. Summation X square means that if you want to find the X, you first of all find the X square first. Because a lot of the answer that you sent to me, I discovered that majority of people don't know the difference between the X squared, summation X squared, and summation X all square. Please note, this is the time for you to get it again. Now, you will first of all square the X. When you square the X, if I squared 1, I'm going to have 1. Square 2, you're going to have 4. Square 3, you're going to have 9. Up to the last one, if you square 7, you are going to have 49. Now, that is what we call the X square. Now, let's check the Y square. If you square 5, we are going to have 25. If you square 13, we are going to have 169. Up to the last one, if you square 40, you are going to have 1600. That is 1600. By the time you do the summation of X squared now is 140. And then the summation of Y squared is 5112. Summation of Y squared is 5112. Now, let's find the product xy. The xy simply means that you are going to multiply x with y. So 1 times 5 will give you 5. 2 times 13 will give you 26. 3 multiplied by 16, you are going to have 48. 4 multiplied by 23, you are going to have 92. 5 multiplied by 33, you are going to have 165, up to the last one, which is 7 multiplied by 40, which we are going to have 280. So by the time we do the summation of x, y now is 844. Please ask question about this table. Which one you don't understand about this table now? Please ask a question if you have question now. I'm seeing 2 people raising up their hands. Please ask a question. Okay, in the absence of none, let us proceed. Now, after this now, I've gotten my parameters to calculate my what? Now, look at this. They even stated it from the question. Roman figure 1, compute the Pearson correlation coefficient and interpret the result. So that means that they want you to use what? A Pearson correlation coefficient. Now, let's go back to our formula for Pearson. Our formula for Pearson, like according to the table that I have, I'm using this second formula. So at your own convenient time, you can use the first formula to confirm the result. You should have the same result. Now, if I'm using that now, let's go back to our table. I've calculated my xy. I've calculated my y square. I've calculated my x square. I've calculated my what? The summation y. I've calculated my summation x. So now let's now move down to the table now. Now, the n, if you recall from the formula, we have n summation xy. The n is 7. 7 means the number of observations that we have. 1, 2, up to what? 7. So that is the meaning of the 7 that we're having there. So we have 7 multiplied by, recall that we have summation xy here. Then from our table, we have xy to be this. Then if you add all of them together, we have 844, which is the summation xy. Now let's go back to this again. So we have minus the summation x. The summation x here means that, wow, supposed to be, can you do this sum for me? Is it 29 or 28? That should be when I was typing it. 1 plus 2, this one will give me 3. 3 plus 3, this one will give me
It should
6.
be 28, sir.
It's
It's
supposed to be
28,
20.
sir.
It's 28, Abby. So it is
Yes,
when I
sir.
was, because I pressed my calculator and it was 28.
It's 28, sir.
28,
Yes,
thank you. So I'm going to correct this by 29. So now we have 28 multiplied by the summation of y. The summation of y, which is what? 168. Can you confirm this for me too? Confirm this summation y for me. What's the answer, please?
Sorry, 168.
168. Good.
168, sir. 168, sir, is
168.
correct.
168. 168. Thank you. So now multiply by what? The summation of y. Now we are through with the what? The
it's
numerator.
168, sir. It's correct.
Yeah, thank you. So now we are through with the numerator. Now let's move down to the denominator. We have 7 multiplied by the summation what? Let's quickly check the formula again. We have n multiplied by summation x squared. So the n is 7. Our n is 7. Then the summation x squared is 140. The summation x squared is 140 minus the summation what? The summation x all square. By now we should know the difference now. The summation x is 28, then you will square it. That's the meaning of summation x all square. Then multiply by 7 times summation y square. Summation y square here is 14. Wow, sorry, let me check. What's summation y square? Is it summation y square? Let me quickly check the formula. Sorry, let me. Summation y square. What's our summation y square? Our summation y square is supposed to be 5112. What's going on? Please, can you confirm the summation y square? Is it 5112?
Yes, sir, it's correct, sir. 5412, sir. It's correct, sir.
5112. So that means that I'm going to check this too. This is supposed to be 5112. Please just be following me like that. I'm going to make all the correction before I send the slide. So it was when I was typing here. Okay. Minus 168 square. What is my 168? My 168 is the summation y.
Sir, excuse me, sir. I think you are correct. In
Okay.
the formula, it says summation y bracket square. So summation of y is 188. But
Yes,
you wrote
this one is
168.
correct. What do you say, sir?
Is 188.
Summation of
No, it's talking now. Excuse me, it's talking about summation y squared, not y squared.
I'm talking about summation y
Sir,
squared.
please write down. Time is going. Oh.
So please, summation y square here. Please let's move our mouse. Okay. So the summation y square here is 5112. So we're supposed to have 5112 here, multiplied by 7, then minus the summation y all square, which is 168 square. Are we together, please? Please, can you confirm the first one, please?
Yes, sir.
7 multiplied by 140, then minus 28 square. Let's see, are we going to have 196? Then another person should also confirm this for me.
7 multiplied by 140, sir.
Okay.
It's 196.
7 multiplied by 140 is 980.
Okay,
What?
minus 28 square.
It's 196.
196, good. Okay. Now, what about the second one? Let's say 7 multiplied by 5112. Please, let's mute our mic. 7 multiplied by 5112. The reason why I'm saying we should be doing it like
It's
this
correct.
together
196 is correct.
Okay. Okay. What about the second one? 7 multiplied by 5112. Then you will subtract it from 168 square. What will be our answer?
7,000.
Correct.
7.
That means you was typing the right thing, but you just made a mistake.
Okay. Okay, because
Correct.
that is what I have inside my. Okay, so this one is correct, but the last, second to the last. The second to the last is correct. Okay,
It's
so I'm going
correct,
to
sir.
make the adjustment for the remaining one. So by the time you do that, we're going to have 0.9891. That will be our what? Our Pearson correlation coefficient. So our Pearson correlation coefficient is going to be 0.9891. What is the interpretation for this? That is, there is a very strong positive correlation between the age and the height. There is a very strong positive correlation between the age and the height. Now, the next question that they ask us to calculate here is coefficient of determination. Coefficient of determination. And then coefficient of determination is simply means that you are going to square your Pearson correlation coefficient. That's why we normally have it as R square. It's either we get our coefficient of coefficient of determination from our Pearson correlation coefficient, or we get it from the regression. And if you want to get it from regression, it's a long process that you have to be calculating and calculating, which is beyond this class. Even those in biostatistics now, I don't think they are also doing that, because they just give them the table and they ask them to interpret. So there's another way to get the coefficient of determination through regression. But from the Pearson correlation, we can get our what? Coefficient of determination. It simply means that you are going to square the value of the Pearson correlation. So when you square the value of the Pearson correlation, you are going to get what we call coefficient of determination. So now if I square this value that we have here, R square simply means I square this, we're going to get our coefficient of determination to be this value now, which is the same as 0.9783. But the coefficient of determination will also express this in percentage. So by the time I express this in percentage, I'm going to have 98%. Now, what is the interpretation of this? The interpretation of this is simply means that out of total variation or variability in height, remember that our height is the Y, then age is the X. Age can only account for 98%. The remaining 2% can only be accounted for by other variable which is not in this work. So that is, if the strength or the relationship between the height and age, that is 89%, can be what? Can be account. Anything you are talking about, anytime you are talking about the age, anytime you are talking about the height, for instance, height is the y, then age will contribute 98% to what? To the existence of height. But the remaining 2% that we don't know is other variable that is not captured here. But 98% out of 100 is what is tending towards perfection. So because that means that the age is very, very significant when we are talking about the height. So this is very, very important. That is this is how we normally interpret coefficient of what? Coefficient of determination. And then all these questions, I think they assign their marks. Oh, I didn't put the mark there. So please and please, this is very, very important. You must know how to interpret your correlation coefficient. You must also know how to interpret how to get your coefficient of determination by squaring your what? Your Pearson correlation. So after getting that, you should also know how to interpret, because the interpretation is also part of, if the total mark for this is 3 marks, let's say coefficient of determination, if the total mark is 3 marks, maybe 1.5 is for you calculating and getting your coefficient of determination out, and then the remaining 1.5 would be for the interpretation, because the interpretation is what people can relate with. If I'm telling people that the coefficient of relation is 98%, what does that one concern me? I have to relate it to what they can understand through what? Through the interpretation. It is very, very important. Any question before we move on? Okay,
Sorry.
let's continue. Although when I check the past question, okay, I'm with you.
When we
Question,
see the question, will they be specific about which one is X and which one is Y? Will they tell us?
Okay. Okay.
Thank you.
Now, if they can tell you and they may not tell you, but one thing that you're going to be looking out for is the one that they mention as dependent is the Y. Because if they change if they change it that the height depend on the age, if they say what? Height depend on the age, so that means that your Y is the height and then your X is the age. The dependent variable is always Y, while the independent variable is X. Do we get that, please?
Yes, sir. Thank you, sir.
Yes, sir.
All right, thank you. Now, after checking past question, I didn't see any question under Spearman, so I just have to go and check one of our non-parametric test notes that I have, so that I can bring out something to relate. Now let's look at this question. I have my X's to be this and I have my Y to be this. Now let's now come back to this, because I'm still going to, after explaining we're going to go back to the first question and now see whether we can use Spearman rank or not. Now, if you look at this X, please, I want us to listen to this and look at it very well. This is our value for X and this is our value for Y. Now, I want to rank X now. That's what I call Rx, the rank of X. Now, please listen to how I'm going to rank it. If you look at this is where we normally rank. The least value here is 2. The least value here is 2, so it is going to take 1, rank 1, followed by 3. 3 is going to take rank 2. Now, after 3, followed by 5. 5 is going to take rank 3. Now, after 5, followed by 7. 7 is going to take rank what? Rank 4. So after that, followed by 8. 8 is going to take rank 5. Then after that, followed by what? 9. 9 is going to take rank 6. Then after that, the last one is 10. 10 is going to take rank 7. Please ask question now for the first rank. Do we get that, please?
Okay, so what
Yes, sir. Yes, sir.
now you have like
No, sir.
two figures that are the same, like you have 7, 7 or 8, 8.
Okay.
How do you now rank it?
Okay. We are going to get to that in my rank. Do you understand the X rank first?
Excuse me, sir. I
Do you
didn't understand.
Okay, let me
Excuse me,
take
sir. Can
the
we
X rank
rearrange on
again.
our own? Excuse me,
Please
sir.
ask your
Can we
question.
rearrange on our own? Like 2, 3, 5, 7, 8, and 9, and we get the answer.
Good. Once you please listen to this, if you want to arrange on your own, you must go along with the conjugate. What do I mean by the conjugate? We have X and Y. If you are taking 1 to be 4, if you are taking 2, please let's move our mind. If you are taking 2 here to be the first one, and you are bringing 2 first, that means that you go and take y. Y here is 6. It will be 6 first. So as you are taking anyone that you want to rearrange in ascending order, it must go with the y. So that means that if you are rearranging x, you cannot rearrange y in ascending order. If it is y that you are taking, let's say for instance you want to take y, 5 will come first. Immediately the 5 comes first, then you will trace it, 10 will come first for x. So that means that you are pairing them together. Do we get that, please? Do
No,
we get
sir.
No,
that
sir.
part?
No, sir.
No.
Okay, let me take it again. Let me take
No,
it
sir.
again. Please let me take it again. Let's smooth our mind. Let me take it again. If you are ranking, is it that you leave the value the way you are given? Or, please let's smooth our mic. Is it that you leave the value the way you are given, or you want to rearrange it yourself? But you only have one chance to rearrange. Is it that you take X or you take Y? You cannot rearrange the two. You cannot rearrange the two. You only rearrange one. Now, let's say, for instance, I want to rearrange X in ascending order. That is, 2 is going to come first. Now, if the 2 is coming first, you will go back to Y. If you check 2 to Y, is 6 in Y. Under Y, we have 6. So that means that as you are taking 2 to be the number 1, 6 also will be number 1 in Y. Now, followed by 3. 3 will come number 2 in X. Then you will go to Y. Trace it is 9 in Y. Y will come to number 2. So that is how you are going to do or rearrange it. Is it that you rearrange like that, or you leave it the way the question is given and you rank it? So now, if you are
Thank you, sir.
ranking it, okay, ma. So if you are ranking it now, let's say I want to rank X. Who is that? Please, can you mute your mic? Okay. Let's say, for instance, we want to rank X. Please mute your mic. Don't let me remove you from the group.
Comfort,
Can you
comfort.
use your mic?
Please help me. Kindly mute your mic, please. You are disturbing us.
Okay. So if I want to rank X now, the least value I'm having in X here is 2. Please, let's be on the same page. Is 2. That 2 will take the rank of 1. It's like you are numbering them. That 2 will take the rank of 1. The next value is 3. 3 will take the rank of 2. Now, followed by what? The next value is 5. 5 will take the rank of 3. Like we are counting 1, 2, 3, 4, 5. Now, 5 will take the rank of 3. After 5, followed by which number? Followed by 7. 7 will take the rank of 4. Then after 7, followed by what? Followed by 8. 8 will take the rank of 5. Then after 8, followed by what? Followed by, after 8, followed by what? Followed by 9. 9 will take the rank of 6. And then lastly, the highest value that we have here is 10. Then 10 will take the rank of 7. That is how we normally rank. Do we get that?
Yes, sir.
Okay. Now let us now go to Y. Please, I want us to listen carefully in this Y ranking, because we have 2 numbers that appears. So now let's start. The least value that we have in Y is 5. 5 will take the rank of 1. Now followed by 6. 6 will take the rank of 2. But we have 2 6 there. Please listen to this. We have 2 6 there. The first one is going to take 2. The second one is going to take 3. But 6 is not greater than 6. 6 is 6. That means that the first one that the first one that will take 2 and the second one that will take 3 is still the same 6 6. That means that you are going to add the 2, the first one, plus the 3 for the second one. By the time you add the 2 plus the 3, is going to give you 5. You will not divide that 5 by 2 because we are having 2 6 there. By the time you divide that 5 by 2, you are going to have 2.5. So that means that each of the 6 will take 2.5, 2.5. Let me take it again. After 5, we have, after the least one here that we have in Y is 5, which is taking the rank 1. Then followed by 6. 6 supposed to take rank 2. But we're having 2 6 there. So we're going to have the rank 2 for the first 6, the rank 3 for the second 6. But the 6 is not greater than 6. 6 is not greater than 6. Now, that means that the first rank that we assign for the first 6, which is 2, plus the second rank that we assign for the second 6, which is 3, we're going to add 2 plus 3 together, divided by 2. By the time we divide it by 2, we're going to have 2.5. Then 2.5 will be administered for each of the 6. So that means that they are going to have the same rank. Let's say, for instance, we have 6 like 3. Let's say we have 36 in this Y. The first one is going to take 2. The second one is going to take 3. And the third one is going to take 4. But 6 is not greater than 6. So that means that you are going to add all those ranks together. 2 plus 3 plus 4. Then divided by 3. Because we have 6 3s there. So immediately you divide it by 3. The value that you have, you are going to put it for each of the 6. So that means that they are going to take the same value. Do we get that, please?
Yes, sir.
Any
Yes, I
question on
understand.
that?
No, sir.
There
Please,
is
my
a
question
question.
is applicable to
Yes,
that
we get
nine.
it.
I
Hold
suppose
on, please.
supposed to be ranked at.
Excuse me, sir. I have a
Okay,
question.
Please hear me.
please go ahead.
Excuse me, sir. When they are doing, excuse me,
Figure
sir.
9 supposed to be ranked at 6.
Excuse me,
Zero.
sir. I have a question on the issue of 2.5, 2.5. Can't
Yes,
we
ma'am.
rank them as 2, 2? Because, for example, in school exams, when you have 3 people having the same score, and you want to rank, just give, assuming that they have, that is the third position. All the 3 will have 3, 3, 3, third position, third position, third position. Can't we put 2 and 2 here, 2? Instead of
Okay,
2.5, 2.5.
good, good.
My observation 9
Okay,
supposed to be ranked as 6.
which one, ma?
9. The first one in Y. Y rank 9. I think it's supposed to be 6.
I didn't get. Is it Y you are talking about or X?
Yes, Y. You know why?
You are
After
talking
we
about.
have our
We've
X
not
is 5.
gotten to why.
Okay,
We are
We've
still,
not
she,
we
gotten
are
there.
still,
what she's saying
we are
is
still
true.
taking it
What
one
she's
Okay,
by
I
saying is
one.
thought
true.
you are talking about. Sorry.
Hello, sir.
Wait,
Please, a
I'm with you.
question.
Okay.
Yes, this dividing of the figure, is it also applicable to X?
It's
In
also
case we have
applicable to
to,
X. It's
okay,
because we don't have number that appear like 2 or 3
twice.
times.
Okay, okay, thank you.
Okay, so let me quickly react to those questions. Ma, if we want to rank those people, ranking is different from position. What you just mentioned now is just position. We are giving them position. Oh, they are in position 333. It's different from you ranking them. If you are ranking them based on their performance, and you have the same people that perform the same way, are we together now? Because if you rank them, let's say for instance, we have 7 students in that class. Let's say we have 7 students, and you discover that 3 of them, they are in first position. By the time you put first, the remaining people in that class will be 4. So now let's now say we've put 4, we've put 1 for the 3 of them. We have 3 left, and you now rank the fourth one to be 2, the next one to be what? To be 3. At the end of the day, you will not get to that 7, which is the total number of observation in that class. We have, like now in our own case, we have the class of 7. By the time you assign the same 3 for them, at the end of the day, you will not get to that number of observation again, and you must get to the number of observation. That means that by the time you get to that number of observation, that means that you have covered the whole class. So in that case, we don't rank in position. The one that you just made mention, ma, is just the position. 3 people, they have 70-70. Oh, they are in third position. It's different from you ranking them. If you are ranking them, you must have the same observation that you have. That would be the same ranking. Let's say, for instance, we have 20 observation in our own question. That means that if you are ranking, your ranking must get to 20. But by the time you you assign 3 for the 3 of them. By the time you start ranking, at the end of the day, your ranking is going to get to 17, not 20. So if the number of observations that you have will determine the number of ranking that you're going to have, then the number of ranking must tally with the number of observation that you have. If you're having 20 observations, you must get to 20 rank. If you are having
Thank you,
7
sir.
observations, you are going to get to 7 rank. Yes, ma'am. Please ask your
Thank
question.
you, sir. Yes, sir. Thank you, sir.
Is it clear, ma'am?
Yes, thank you, sir.
Okay. Now
I
let me
want
take.
to,
Okay, ma'am.
please, sir, the second column for Y, is it YR or YY? Is it intentional?
It should be Y. It should be RY. Thank you for that.
Okay.
It rank Y. It should be RY. It should be RY.
Excuse
That
me,
is
sir.
for rank
Hello,
Y.
sir.
Yes, ma'am.
Sir, can you take the ranking again? Thank
Excuse me,
you.
sir.
Yes, ma'am.
Excuse me,
Please
sir.
Hello,
go
sir.
I
ahead.
have a question,
Hello,
sir.
I'm
sir.
with you. Go ahead.
The question is actually my network broke as at the time you were trying to say 98% for coefficient of determination. So I think from that slide, this is the next slide you are now after that one. So though I have
Yes.
question then there, but a lot of people were talking. So the question I just asked is that you were saying the other 2% were factored in due to other variations. So now the age itself, when we have age 1, age 2, age 3, naturally um let's say from that value there are different samples, different age groups, so there are variation within the age. Why can't you just say the other 2 factors, the age is also contributing to it, since it's part of the question?
I did. This is. Please listen to this.
No, to me,
The interpretation of coefficient of determination is this: all your independent variable, they contribute to the variation of dependent variable. But you cannot, no matter what, it is only God that have 100%. You cannot capture all the variables that contribute to the outcome of a very dependent variable. Let's say, for instance, your height. Your height is determined by, according to this question, the age determine the height, which is 98%. What about the food that you are taking? What about the water that you are taking? I don't know maybe what I'm trying to say. So, it's other variable that is not factored in at the remaining 2%. Not that we have 1%, 2%, other variable which you don't even know. So that is how we normally interpret the coefficient of variation. The total variation in your outcome variable is always 100%, but your independent variable is contributing to the output. So you will check the percentage of your contribution of your independent variable. So the remaining percentage that you are left with are the variable that is not captured in your in your model or in your research. So please, for those you for the
Excuse
network
me, sir.
broken, please you will get the access to the audio so that we'll continue moving. Okay, ma, you have your
Hello,
question.
sir.
Yes, sir.
Hello, sir.
Those variables, can we call them extraneous variable or confounding variables that are not that are not part of what we are given?
Extraneous variable. Yes, we can call it extraneous variable, but
Thank you, sir.
we cannot call it confounding variable. We cannot call it confounding variable because when you're talking about the confounder, you know the variable already. You know the
Okay,
variable
sir.
already.
Thank you, sir.
Okay. Bro Moses, ask your question quickly, sir.
Yes, sir. Sir, please, I want you to kindly check the ranking for 9 ranking for Y for number 9.
Okay. We're going to get
Of
there.
variable 9. Yes, sir. Thank you, sir.
We're going to get there. We're going to get there. We're going to get there.
Thank you, sir.
Okay. So, So if you look at this now, we have 2.5, 2.5. Now, remember that it is 2 and 3 that we added together, then we divide by 2. So that means that our rank stop at 3. Our rank stop at 3. So the next rank is 7, which is going to take 4. Remember that our rank stop at 3. So the next rank is going to be 7, which is going to take 4. Now, The next rank is 8, which is going to take 5. Now I can see what you are saying now. The next rank is what? Is 8, which is going to take 4. And then the next rank is 9, which is supposed to take 6.
Yes, sir. Yes, sir. Thank you, sir.
It's supposed to take 6. Please note that in your notes. The next rank is 9, which is supposed to take what? 6. It's supposed to take 6. And then the last one is 7, which is taking 7, which is the last one is 10, which is taking 7. If you note this, by the time I do the subtraction, it's supposed to be 2 minus 5 minus 6, which is minus 4. So I have, before I typed, I have them solve inside my note. So it is the process of typing that error occurred. I'm going to amend that with my note. So quickly, for those people that join late, please, I will take this for the last time. I'll take this rank for the last time. For those people that join late, please listen. Now, if you want to rank X, how many observations do we have? We have 7 observations. That means that our rank will start from 1 and it will end at 7. Our rank will start from 1 and it will end at 7. Now, come back to your observation for X. Starting from the list here is 2. It's going to take rank 1, followed by 3. 3 is going to take rank 2, then followed by 5. 5 is going to take rank what? Rank 3. Followed by 7. 7 is going to take rank 4. Followed by 8. 8 is going to take rank 5. Then followed by what? Followed by 9. 9 is going to take rank 6. Followed by what? The last one, which is 10. 10 is going to take rank 7. That is how we normally rank. Now let's come back to Y. Remember that we also have 7 observations for Y. That means that your rank starts from 1 and is going to end at 7. Now let us now look at this. The list here is 5. 5 is going to take rank 1, followed by 6. 6 is going to take rank 2, but we have 2 6 there. So the first one is going to be rank 2, and the second 6 that we have here is going to be rank 3. But 6 is not greater than 6. So that means that we are going to add the 2, the first one, the 2 plus the 3. The rank for the first 6 is 2, while the rank for the second 6 is 3. We are going to add the 2 together and divide by 2. By the time you divide by 2, we are going to have what? 2.5, because 2 plus 3 is 5. 5 divided by 2, we are going to have what? 2.5, 2.5. Let's say your rank, you have more than 6. Like we have like 36 in this question. So that means that the first one is going to be 2. The second one is going to be what? 3. And then the third one is going to be 4. So that means that you're going to add 2 plus 3 plus 4 divided by 3. So the answer that you're going to have will be the rank that you're going to give to the first 6. You give it to the second 6, and you give it to the third 6. But in this our own case, we have just 2. We have 6 for the first one, which is going to take rank 2. And then we have 6 for the second one, which is going to take rank 3. So now 2 plus 3 is going to give us 5 divided by 2. It's going to give us 5. It's going to give us 2.5. So 2.5 will go for the first one, and 2.5 will go for the second one. So now, remember that we stop at rank 3. The next rank is going to be 4. So 7 is the next number. It's going to take rank 4. Then followed by 8 is the next number. It's going to take rank 5. Followed by 9. 9 is the next number. It's going to take rank 6. Not the 5 that I wrote there. It's going to take rank 6. Now, the last one here is 10. 10 is going to take rank 7. That is how we normally rank. Now, the D, remember that from the formula of Spearman rank, we have D. This is the D. How do we get the D now? The D is the difference between the rank of corresponding value of X and Y. Let us now go back to where we have the rank. So that means that the rank X minus the rank Y, that is 2 minus 6, is going to give us minus 4. 1 minus 2.5, we're going to have minus 1.5. 7 minus 1, we're going to have minus 6. 4
No, sir.
minus 4. Yes,
Hello,
sir.
sir. 7
with
minus
you.
1
But
should give us
to ask,
positive 6, sir. Kindly
Oh,
check it, sir.
good.
Thank you, sir.
7 minus 1. We're supposed to have 6. Thank you for this. Please let me note that correction too. 7 minus what? Minus 1. We are going to have 6. Good. Then 4 minus 4. We are going to have 0. Then we have what? 5 minus 7. We have minus 2. Then 3 minus 2.5. We have 0.5. Then 6 minus 5. We're going to have 1. Then we find our d square. By the time you square this, we're going to have 16. By the time you square this, we are going to have 2.25. By the time you square this, we're going to have 36. By the time you square 0, we're going to have 0. By the time you square minus 2, we're going to have 4. By the time you square 0.5, we're going to have 0.25. By the time you square 1, we're going to have 1. We have our d square. Now, after getting our d square, remember that in our equation, we have summation d square. Summation d means that
2
summation d
minus
square
5
means
is
what?
minus 3, oh, not minus 4.
What do you say, ma?
Can you hear me?
I can hear
2
you, ma.
minus 5 is,
I
sir,
know.
2
We
minus
we
5 is
mentioned,
minus 3, not
yes.
minus 4.
When we are ranking, please listen to this. When we are ranking, I'm going to send the correct slide. I'm going to do the correction. I'm going to send it to the group. 6, we're having rank 6 here, not rank 5. Remember that 8 here is ranked as 5. So 9 is supposed to rank as 6. So 2 minus 6 is minus 4. Do we get that, ma?
Yes, sir. Thank you, sir.
Okay. So now, by the time we do the summation of d square, then let's have this. Okay. So we have this formula now. Now I'm going to have 1 minus 6. Summation d square is 595. Summation d square is 595. So by the time I multiply this 6 times 500 and this divided by the total observation that we're having there is 7 into
Hello, sir.
brackets. Yes, sir.
Hello, sir.
I'm
I
with you, sir.
think summation d square is 59.5, sir. Kindly check it, sir.
Is 69?
59.5. 59.5, sir.
59.5.
Yes,
Oh,
sir. Kindly check it.
okay.
Just kindly check it, sir. Maybe I might. Someone should kindly verify because I might be wrong too.
With that. Please, can you do the
Yes,
summation?
it's
It will be
59.5.
59.5. So point
Yes,
is
sir.
missing here. What's going on with our slide this night? Sorry for that. I'm going to make that correction. Can you multiply 6 multiplied by 59.5? What's the answer?
357, sir.
357.
357, sir. You are right. 7.
357. 357.
Yes, sir.
Okay.
It's just points that is missing, sir. Point.
Okay.
Thank you, sir.
357. Okay. Now 7 into bracket 49 minus 1 will give us 48. 48 multiplied by 7. Do we have this?
336, sir.
Okay, good. I think I love this class. It means that you are with your calculator, your biro, and book.
Yes, sir.
So you are cross-checking everything. This is very good. Thank you. So I was able to know that there is point missing here. Okay. So by the time we do the division,
Excuse
do we
me,
have
sir.
1 points? I'm with you.
1.0625.
I'm with you, please.
Hello. So, excuse me. In the calculation for the table d square, we omitted 6 raised to power 2 because we calculated 7 minus 1 is 6, which should mean we should have 236. So if we add 36 to the 59.5, those will be 95.5. I don't know if you understand what I'm saying.
And yes, it's 90. It's supposed to be what? I didn't get. What do you say we omitted?
7 minus. Oh, Oh, I'm sorry. I'm sorry. I've seen the error. Thank you very much. I'm sorry.
Okay, no problem. Okay, so by the time we do this division now, what do we have? 1.0625. Subtract this, what do we have? We're going to have minus 0.0625. Class, what is the interpretation for this? Based on the knowledge of interpretation, what is
Sir,
interpretation for this?
the interpretation is that there is negative, weak, moderate correlation.
Strong negative correlation.
Weak, negative, weak,
Negative
negative,
monotony.
moderate correlation. This one is moderate, 0.06. Negative, moderate correlation. It's negative.
Negative monotonic relationship also.
So is for me, I think is a negative monotonic correlation. Sorry, negative monotonic relationship. Negative monotonic relationship, sir.
Negative weak correlation.
Mine is negative, moderate correlation.
Because it's 0.06. So it's 0.06 is negative weak correlation.
Okay, thank you so much. We've tried. So if you look at this, can you see my screen?
Yes, I can see your screen, sir.
Okay, let's quickly go back to, because I want us to get it. Let's quickly go back to this. Anytime you're having this, we'll call it what? Perfect positive monotonic relationship. Anytime you have the negative, we have perfect. When you have minus one, we have perfect negative monotonic what? Relationship. Now, if you look at that value that we have, it is weak, very, very weak. Very, very what? Very, very weak. So that is what we call what? A weak negative monotonic relationship. A what? A weak negative what? Monotonic relationship. I made mention of this, that is the difference between what the Pearson interpretation and the Spearman rank. Is that word monotonic? Is very, very what? Is very, very important. So that's why I leave it. I don't want to write it. That when we get to the class, based on the knowledge that we've acquired, we should be able to interpret it. Any question before
Yes,
we?
sir. I have a question, sir.
Go ahead.
No, I have a question, sir.
Please go
The
ahead.
question is this: how do we determine whether a correlation is weak or strong? Because I read somewhere that we have a strong correlation, moderate correlation, and weak correlation, and they gave a value ranging from
Okay.
0.3 to 0.4, then 0.5 to 0.6 or 7,
Okay.
then from 0.7 to 10 as strong
Okay.
as 0. As strong correlation, and so on. I read somewhere.
Okay. Okay. Now, I don't know, maybe Grandma, you joined late because we've explained that. Now, we have range of value. And I gave the other time I made mention that anytime you're having one, that is perfect. If it is positive, that is positive perfect correlation. But in the case of the Spearman, it is called what? Perfect what? Positive monotonic
correlation.
Yes. Now, if it is negative, that is what? It's also perfect but negative. But anytime you are having from 0.75 up to 0.99, it is called a very strong positive correlation. A very strong positive correlation. Do we get that one, ma? Now, anytime you are having from what? 0.5 up to 0.75, sorry, 74, we have what we call a strong positive correlation. A strong positive correlation. But anyone that you're having from 0.9, 0.49 downward, it is called weak. But sometimes they categorize weak into two. Is either you have a very weak correlation. That one starts from something like 0.34, but they are still in the categorical of what? Category of weak. Do we get it, Grammar?
Yes, sir. Thank you, sir.
Oh, okay, good. Any other
So
question?
please, I have a question, sir.
Please go ahead.
Please, can you explain what the monotonic means? This is the first time I'm coming across that word.
Okay, monotonic. Now, monotonic simply means that is it increasing or decreasing? From the word mono. So it either means that, oh, is both x and y increases or x and y decreases. So if it is increases, we call them monotonic. We normally use that word in when we are using, what's it called? When we are using Spearman rank. When we are using Spearman, because in our normal PSC, we can just say as y increases, x decreases. That is inverse. Oh, let me use the word inverse. We normally use inverse. Inverse simply means that as one is increasing, the other one is going down. And then the direct means that as one is increasing, the other one is going down. But in the case of the Spearman rank, it means that they are increasing together and they are decreasing together. That is what they mean by the monotonic increasing. Oh, that means that the x and y, they are increasing together. But if it is monotonic decreasing, that means that x and y are going down together. Do you get that concept, Ma?
Yes, thank you so much, sir.
All right, you are welcome.
Yes, sir. I have another
Sorry,
question, sir. Sorry, I'm not taking you back, sir.
Okay,
Sir,
ma.
this formula, you wrote P, and you say when you want to, they usually call Spearman row something.
Yes, man. That symbol that you are
putting
seeing,
P.
that symbol that you are seeing, man, is not P. It is a row. That is Greek letter of writing row.
Okay.
It's like I'm writing alpha. I'm writing beta. That one that you are seeing
Okay.
there is what we call the symbol for row, the Greek letter.
But sir, can we write RH?
You can RHO. You write RHO. That is
RHO,
row.
yes. Okay.
You can write this row.
Thank
They will
you.
mark it for you. But if you are a
Okay, thank you,
statistician and you
sir.
are writing row, they will not mark it. Oh.
I'm not a statistician, no, I'm a nurse.
Okay, another question, please.
Please, sir, I want to quickly clarify something. Minus
Please go ahead.
0.52 minus 0.74 is strong negative correlation. Am I correct, please?
Yes, you are correct.
And minus 0.49 downward is weak negative correlation.
You are correct, man.
Okay, thank you, sir.
All right. Okay. In the absence of no, let's move down to the regression. Let's move down to regression. Now, normally, the main usefulness of regression is that we normally use it to find the joint contribution of variables. I want to bring them together and see their effect on the outcome. So that is why we normally use regression. If you check the correlation, the highest value that we can have is we have one y and one x. We can't have two x's in correlation, no. And we can't have two y. Y cannot be more than one, x cannot be more than one. But if we want to have x that is more than one, y that is more than one, we normally use regression. We normally use what? Regression. Now let's quickly go down to what I have here. Regression analysis is a powerful statistical technique used to understand the relationship between a dependent. Another name for dependent variable is called the response variable. It's called what? A response variable. Another name for dependent variable is what we call the what? The outcome variable. Another name for dependent variable is called what? The outcome variable. Then another name for dependent variable, it is what we call the effect variable. I think I've given like 3 or 4 names now. It is very, very important. In case you are asked in the question and they did not put dependent variable that you are familiar with, and they go and put something like effect variable, it's still the same thing as dependent variable. Or you will see response variable. It's still the same thing as what? Effect variable, which is also dependent variable. And one or more independent variable. It can take one independent variable, and it can take more than that. It can take more than one X. The another name for independent variable is what we call the predictor. We call it the predictor variable. Another name for independent variable, we can also call it explanatory variable. The another name for independent variable, we can also call it treatment. Treatment. You take in drug, that is treatment. Then the effect of that drug is the reward, is the what? The outcome variable. So that's what we have mentioned, like 4 or 3 names now for what? For independent variable. Now, it is widely used in various fields, include economics, biology, engineering, social sciences, then to make prediction. For instance, now, the excess of we carry out the regression is that we want to develop a model that we can use to predict. A model that you can what? That we can use to predict. Give me X, I will tell you the outcome of Y. Give me your test score, I will predict what you have in your what? In your exam. Give me the hours of sleeping, I will give you what? Give me, I'm going to give you your weight. Give me your age, I'm going to tell you your height. Give me your age, I'm going to tell you your body mass index. So anytime you are having a model, we normally use regression to create a model that we can use to predict. And what is a model? A model is just a mathematical representative of real life situation. We normally use our figures to represent it, but in a nutshell, we normally use it to represent a real life situation. So let us move so that I will not bore you with all the terminology that we normally use in statistics when it comes to regression. But let me just go down to your level, to the level of 727, so that you can quickly understand this. So let's check the next slide.
Sincere apologies, sir. The outcome variable, did you say it is the independent or the dependent variable?
The outcome variable is the dependent variable.
All right, thank
Dependent
you, sir.
variable. Yes. Okay. Key concepts in regression. What are the things that you have to familiar with when you carry out your regression? We have dependent variable. I put Y here so that you will know that your dependent variable is your Y, which is also the outcome variable. The outcome variable, target or response variable, we are trying to predict or explain. I've mentioned that we are trying to predict X. We are trying to check the outcome. We're trying to check the response variable. So that is what we call the dependent variable. Now we have independent variable or variables. That means that we can have more than one X. The predictor, we call it predictor or explanatory variable that influence or predict the dependent variable. So that is what independent variable. Then we have what we call regression coefficient. Regression coefficient, we normally call it beta. So if you want to write it in English, is beta. But this letter that you are seeing here is the Greek letter, like the rho and that symbol that I wrote the other time is a Greek symbol. So this is what we call the beta. The constants that quantify the relationship between each independent variable and the dependent variable. If I'm going to show you the equation now, in which we are going to be having what? Your dependent variable, your independent variable. So then we are going to be checking the coefficient of your what? Of your independent variable. Don't worry, when we get there, you will understand better. Then we have the intercept. The intercept is the expected value of dependent variable when all independent variables are equals to 0. If you are plotting your graph, let me use graph. Don't let me use the grammar that they are using here. When you plot your graph and you draw that line that we normally do, which is called the line of best fit, if you remember from our mathematics. So anywhere the line touches Y is what we call the intercept on Y, and anywhere the line touches X, it is what we call the intercept on X. Don't worry, we are getting there now. Then we have what we call the residual. A residual is the same thing as your error. because you may pick up journal and you are seeing residual there. It's still another name for error is what we call the residual. The difference between the observed and predicted value of the dependent variable. Let's say, for instance, we have the dependent variable which are y's. We have y1, y2, y3, y4, up to y7. Now, after we've calculated our regression, we have a regression model. The regression model is that give me the value of x, I'm going to predict y. Give me the value of x. Give me the value of x1, I'm going to predict y1. Give me the value of x2, I'm going to predict y2. We use that model to predict. Now, that y that we are predicting is what we call what? The predicted value of y. So now, if you're now finding y, the original y, the y that we are given, the value of y that we are given minus the value of y that we predicted, it is what we call the residual, which is the error. Let me take that again. The y given from the question is your what? Is your dependent variable. After you've calculated your beta, you've gotten your model. I told us that the model is, we normally use it to predict. Give me the value of x, I'm going to predict y. Now, let's say, for instance, you are given the value of x to be x1 to x5, and you want to predict y, y1 to y5 to y5. Remember that you have been given the original y before, which is your dependent variable. Now, if you now predict that y1 to y5, you have a value for it. Remember that you have your original value of y. Now, the difference between your original value of y and the y that you predicted is what we call what? The error or the residual. Okay, let's check the type of regression that we have. In this case, I think I listed like 4 type of regression, but it's only 1 or 2 that we're going to talk about, which is partaking to this level. Other regression, maybe you are doing your PhD or you are doing advanced statistics, you will come across that. Okay, the first one is what we call the linear regression. Linear regression. The word linear means that they are what? The relationship is direct. If y is increasing, x will also increase. If y is decreasing, x is also decreasing. So that means that their relationship is direct, like our variation, direct variation. So that means that their relationship is what? Is direct. Now, under the linear regression, we have 2 types. There is what we call simple linear regression. In simple linear regression, you only have one independent variable, one x and one y. That is, we have one dependent variable and then we have one independent variable. In that case, we have what we call a simple linear regression. When you have one dependent variable and one independent variable, you have what we call a simple linear regression. It is very, very important. Now, the y that you are seeing here is what we call the dependent variable. Then the beta naught that you are seeing here, or beta 0, is your intercept, which I've explained the other time. Then the beta 1 that you are seeing here is the coefficient of your independent variable. The beta 1 that you are seeing here is the coefficient of your what? Of your independent variable. Now, the error that you are seeing here is the residual. The residual is what? Is the difference between your y, the original y, and then the predicted y. That is this error that you are seeing here. The error is still the same thing as your what? Residual. Please, I'm still going to give room for question, but let us continue like this. When we get to the example, we understand better. I'm still going to give room for question. Please be writing down your question now. Now, what is y? Y is the dependent variable. What is x? X is independent variable. What is my beta naught? Beta naught is the intercept. This is supposed to be beta 1. Beta 1 is the slope, not the beta naught. Beta 1 is the slope. Then what is my e? E is the error term, or then it's not e actually. Let me tell you the name that they normally call it in case you come across that in journal. It is called epsilon. It is called epsilon. So the epsilon, it is the what? The error term. But for those people that are not statisticians, they normally call it e, but it is epsilon. Let's say you are doing advanced statistics and you are doing your PhD. Don't go and call this e. It is called epsilon. Okay. Now, The other thing that we have, the other one, remember that I say we have a linear regression, and then I have Roman figure 1, which is simple linear regression. The next one, which is number 2, is what we call Roman figure 2, is what we call the multiple linear regression. The only difference between linear regression and multiple linear regression is that the x is more than 1. Anytime you have your independent variable or your explanatory variable or your predictor variable or your treatment that is more than 1, it is no longer a simple linear regression, but a multiple linear regression. Extend simple linear regression by considering multiple independent variable. That means that your independent variable is more than 1. That is what we call multiple linear regression. The other type of regression that we have, which is beyond this class, is what we call the polynomial regression. In that case, instead of having normal x, your x will be raised to the power of 2, raised to the power of 3, like a quadratic, but it's beyond this class. Now, the another regression that we have is what we call a logistic regression, in which most of us will be making use of that when we are doing our project, our analysis in the third semester. It is called a logistic regression. I'm still going to organize a particular tutorial on logistic regression, not for 727, for those people that want to do their project by themselves and they want to understand the analysis. So it's very, very important. So logistic regression, the difference between the logistic regression and the normal regression, linear regression, is that instead of having your y as a linear, as 1, your y will be two response. Your y will be nominal. Let me put it like that. By now, we should know the meaning of nominal. Nominal means that you have two response. Is either yes or no. Is either failure or or success. We normally use logistic regression when your dependent variable or your outcome variable is dichotomous. Dichotomous from die means 2. So is either yes or no. Is either female or male. So that is when we normally use logistic regression. And then most people in public, especially the HPE and HPM, they normally make use of logistic regression very well when they are doing their analysis. Another regression that we have is what we call the ridge and lasso regression. We have the ridge and lasso regression. So this one is advanced regression. When you are doing your PhD, you'll be seeing ridge and lasso regression. Then another one is what we call the quartile regression. Instead of taking our observation 1, 1, 1, 1, we divide it into quartile. We divide it by 4, and then we take the regression quarterly. It is what we call the quartile regression. It is beyond this class. So as far as this class is concerned, we'll be checking linear regression, which is under linear regression. We're going to be checking the simple linear regression and the multiple linear regression. So now, how do we get our beta 1? Our beta 1 simply n summation xy minus summation x summation y. This one that you are seeing here, beta 1 that you are seeing here, is strictly for simple linear regression. That is, you have just one dependent variable and one independent variable. You have one x and one y. This multiple linear regression, they cannot ask you to calculate the beta for the multiple linear regression. Is beyond this level, because in that case, we are going to be using a matrix to solve that, which is beyond this level. So as far as this level is concerned, it is only simple linear regression that they can give you. If they are bringing multiple for you, they will rather bring a table and they will ask you to interpret, or they will ask you to write out the model, in which they brought last year. The last year past question is number 6B. Is under multiple linear regression. And then we discovered that 99% of the candidates, they cannot solve it. They don't even touch it because they don't know it. 99. I don't want to say 100, but 99%, they don't know. They don't even touch it. And you will see it now when I'm explaining that it's very, very simple. So when I'm explaining it now. Now, this beta 1 is strictly for when you are having one dependent variable and one independent variable. That is, you are going to have n. N is the number of observation. Then xy minus xy minus summation summation x summation y divided by n into n summation x squared minus summation x all square. Can someone tell me this one? What is the difference between this and the Pearson correlation?
In
What is the difference
Pearson,
between this?
the numerator for this is the same thing as in Pearson, but the denominator,
Okay.
there is no square roots and
Okay.
no squares, and there is no y.
Okay. Thank you. Thank you. That's the difference. That's the difference actually. The numerator of Pearson and the numerator of the what? The coefficient of what? Of regression. They are the same. The only difference is that the denominator is what? The denominator must be the what? For the regression, it must be what? It must be your what? Independent. That is, we are considering only x, not x and y in the case of what? Of a Pearson correlation. Now, how do we get our beta naught, which is the intercept? Remember that from the first formula, that equation 5, you've gotten your beta 1. Now, come back now. We have our beta naught to be equals to y bar. Y bar simply means that summation y divided by the number of observation. Y bar is your mean. Y bar is the average. Y bar is the expected value. So don't be deceived by y bar. Y bar simply means that add all the observation of y together divided by the number of observation. You get your y bar. Then minus the beta 1 is your coefficient. Is your what? Is your coefficient what? Coefficient of what? Of regression. Your beta 1 is what? Is the what? Is your coefficient of regression, which you've calculated from equation 5. Multiplied by your x bar is mean that your independent variable find the mean. That is, sum all the value of x's together divided by the number of observation. You will get your x bar. So by the time you multiply your beta 1 multiplied by the x bar, subtract it from y bar, you will get your beta naught, which is the intercept. Which is what? Which is the intercept, which we have in equation 6. Now, equation 7, you see that is different from the y bar is in equation 5, is in equation 6. But equation 7, the y that you are looking there is what we call the y hat. It's not y bar. Look at what is on its head. Is at, not bar. Now that y hat that you are seeing is now the number 7 that you are seeing now is not the predicted what is now what is now our model that we can use to predict. If you look at that model now, we cannot find error there again compared to the first one that we have, which we have the epsilon e here. By the time you have a predicted model, your predicted model, by that time you will not have error again. By the time I want to predict this now, I will have find my beta naught. Beta naught value will be here, plus I will have find my beta 1. Beta 1 value will be here. So I will just left with give me x. If you give me x, I'm going to produce y because I know the value of beta naught already. I know the value of beta 1 already. The only value that I don't know is x, which is your dependent variable. Supply me x. Supply me the age of this student. I'm going to predict the height. Supply me the level of sugar. Okay, supply me the sugar intake of this person. I'm going to predict the what? The blood pressure. So you have a model now that you can use to predict. Before we now go to the example, please ask question. The floor is now open. All the questions that you've jotted so far, please ask it now. Thank you.
I have a question,
Sir,
sir.
I have
Thank you
a
very
question.
much, sir. Thank you very much, sir, for the wonderful lecture. Sir, please, I want to know if the beta 1 is the same thing as low and also the same thing as coefficient of regression. That's my question, sir.
Okay, let me quickly answer that. Now, it is when we go to statistics that it's changed to your coefficient of regression. When we are talking about regression, remember from our secondary school, our beta 1 is our gradient, which is our slope that we normally do in physics. The change in y over change in x, that we are going to have y2 minus y1 over x2 minus x1 is still the same beta 1. But the way we calculate it here is different from, because we are not plotting any graph here. You know, we are going to plot a graph in our gradient when we are doing your what's it called, under the quadratic equation. under the linear equation. So that we normally have, we're going to have y2 minus y1 over x2 minus x1. It's still the same beta naught. It's because now we are now in advance. That's why we are calling it coefficient of regression. Oh yeah, another person, your question, please.
Thank you, sir.
Yes, sir. My question, sir. This beta naught
Can you
is
hear me,
having the
please?
sign. Yes, sir. I have
Okay,
a
ma.
question, sir. This beta naught in the, I'm not seeing the screen again.
Please go ahead, ma.
The beta naught in the last equation, sir. It has the heart sign. Is still the same thing as the beta?
You're not seeing the screen
Beta
again.
naught. I'm seeing it now, sir.
Can you see the screen now?
In the last equation, yes, where we have y hat. The beta naught there also has a sign of heart there. And the beta one too also has a sign of heart on it. What's the difference
Okay.
between all this
Now,
beta one, beta
thank
naught?
you, man. And beta art. Good. All the art, anywhere you are seeing art, that means that they've estimated that particular parameter. That means that they have the value for that parameter. Anywhere you are seeing art, you know, we've calculated
Okay.
our beta one here. That's why I'm putting art. So that
Yeah.
means I have a value for it. We've calculated our beta
Okay.
naught here. That's why I'm putting art, because we have value for it. So
Okay.
anyway, you are any parameter you are seeing art, that means that they have value for it.
Okay.
Any other question,
But
please?
why the y hat nko, we don't do we have value for the y hat too?
We don't have value for the y hat, but we want to predict it. Do you get it, man? So that means that give me the value of x, I'm going to have the y hat. That's the meaning.
Okay. Thank you, sir.
Okay, sir.
Thank
Yes,
you,
ma'am.
sir.
Sorry,
Yes, ma'am.
I have a question, sir.
Okay. Another
So
question, please.
doesn't yes, please. Can you hear
Go
me,
ahead,
please?
please.
Okay, thank you, sir. So does it mean that our
I can
first
hear you. Go ahead,
equation where we
please.
okay, so I'm asking that does it mean that our first equation where we have the beta naught plus beta 1 x plus e, we won't be using it afterwards after getting the b1 and b naught? Like we won't be using the error, we won't need to get the error term. That's what I'm trying to ask.
Good. Good. Now, immediately, there is what we call a crude. Crude means that something that you have not refined. That's why we're having error. So now, immediately you want to have a model that you can use to predict, a model that you want to use to predict must be free of error. So by the time you calculate your beta 1 and beta naught, in the process of doing that, we're going to have a predictive model, which is not include error. You see this beta 1 that you are seeing, there's what we call a least square method to use to estimate or minimize the error. By the time we go about the least square method, at the end of the day, we're going to have this formula. This formula that you are seeing in equation 5 was derived from the least square. It was what? It was derived from the least square, but it's beyond this class. So anytime you are having a predictive model, the predictive model must be free of error. Any other question, please?
Thank you, sir.
So I have a question.
Go ahead, please.
What are the major differences between correlation and regression?
Okay. Correlation make use of what we call how will I put it? Correlation measure the association, and then the regression measure the joint contribution. That's number one. Then number two is that there is nothing like beta naught, beta 1 in correlation, but there is in regression. Then number three is that you cannot use a correlation to predict. We only want to establish the strength of association, but we can use a regression to predict. That's number three. Number four is that the parameter of regression, the dependent variable of regression can be more than one. Sorry, the independent variable of regression can be more than one, but that of correlation cannot be more than one. Are we still together? So many
Yes,
like
Yes,
that.
sir.
But the similarity is that if you are calculating your coefficient for correlation, you are calculating your Pearson correlation coefficient, and you're calculating your regression coefficient. They both have a numerator as the same, like the one that we have. If you check the formula, they have what the same formula for their numerator. I think that's just the similarity between them. Any other question?
Can you come again with the differences, please?
The difference is okay, let me take it again. But if I cannot get it the way I put it again, you can watch the video, then you get it. Now, the first one is when we are talking about the correlation, we only have one independent variable. Then regression can be more than that. Then the next one is that the correlation check the strength of association, but it cannot check the joint effect. But the regression can check the joint effect. Then in correlation, we'll be talking about the rule. Sorry, we'll be talking about we're talking about the coefficient of correlation, which is in Pearson, or we're talking about the rule, which is in Spearman rank. But in regression, we'll be talking about what the beta not the beta 1, which is the coefficient and the intercept. There is no intercept in correlation, but there is intercept in regression. I didn't mention that one the other time, Seth. So many we have a lot of differences in correlation and regression. Any other question before we check the question that we want to solve now? Any other question, please? Okay,
I think
let's
we can
quickly
go on.
check that
Thank you.
question. All right, thank you. Now, the following is a stata printout of regressing placenta phenacetin. Remember that, I don't know, phenacetin, they really use phenacetin in the last exam because the question 2 is also on phenacetin. So plasma phenacetin on age and cigarette smoking. Look at this now. Phenacetin here is the dependent variable. Look at this. They regress phenacetin on what? Age and cigarette. Immediately you see the age and cigarette. Age and cigarette smoking. Age here is dependent variable 1, and then the cigarette smoking is what? Also, sorry, the independent variable 1, and cigarette smoking is also independent variable 2. What type of regression are you going to suggest for this?
Please come again, sir.
Okay.
Multiple linear
The
regression.
following.
linear regression.
Why?
We have two independent variables.
Two independent variables and one
We have
dependent
two
variable.
independent variable. Good. Let me quickly take it again. If you look at this question, the following is a stata printout. That is, they run the analysis using a machine, a software called Stata. It's one of our software that we normally use in statistics. So they use Stata to run this analysis. You know, I told you they cannot ask you to use AND as far as this level is concerned. For you to carry out multiple linear regression with AND is not possible for this level. Now, they use machine called Stata to run this analysis. Now, they regress this plasma phenacetin on age and cigarette smoking. That is your what? Phenacetin is your dependent variable, is depending on age and cigarette smoking. So now, your independent variable that you're having here is 2. Number 1 is the age. Number 2 is what? Cigarette smoking. Do we get that, please?
Yes.
Do we get that, please? Okay. Now let's look at the table. This is not the outcome of the table. This is how they will give you. They will give you this. Can you still see my screen?
Yes, sir.
Can you see my screen?
Yes.
Hello. Okay, can you hear my voice?
Yes,
Yeah, we
sir.
can see your screen.
Good.
I can hear the sound of your voice, sir.
It's not showing again.
We can see your screen, sir.
Okay. Now look at this table. Okay, look at this table now. You know, this is our last class. And based on the knowledge that you've acquired so far, you'll be the one to interpret this table for me. I have the interpretation, but I want you to interpret it. Now, look at the first one, the first column. We have the phenacetin level. We have the age. Then we have the smoking status. Now, in smoking status, based on the knowledge of constituency table that we have, based on the knowledge of chi-square, smoking status is a categorical variable. Is it that you are someone is smoker or not? Do we get that, please?
Yes,
Do
sir.
we get that, please?
Yes, sir.
Okay. Now, we have the age. The age is continuous because we have the value for it. We have a numeric value for it. Then the next one, we have the smoking status. Then the CONS that you are seeing there is what we call the constant, which is your beta naught. The constant is the beta naught. It's also called the intercept. So when you run the analysis using system, it will bring out this result. So if you are seeing CONS, don't be asking, is CONS another variable? And you'll not be saying that we have 3 independent variables. No. CONS there is a constant, which is your intercept. Do we get that, please?
Yes, sir.
Because I want you to get this. Because according to statistics now, 99% of people did not answer this question. So there is tendency that they will repeat. There is higher probability that they may repeat this question. Because once they discover that majority of people don't solve it, that means that they don't know it. So that question will just be sitting down in that particular section. So, and I want you to get it so that you can do it if they bring it, because it's simple. It's just interpretation. Now, there's no calculation. You don't need to calculate anything here. You don't need to cram any formula here. It's just your understanding and the interpretation. Look at the second row. The second row is the coefficient. I've explained the coefficient. These are your beta that we have, the beta naught. In this case, what is our beta naught in this case? What's our beta naught?
-0.064.
Minus 0.064.
Good.
As you explained, sir.
0.64.
Yes,
Good. Because that is the constant. Yes. That's our beta naught.
that's the intercept.
That's our what? Beta naught. That is the intercept. Good. That is the intercept. Now, remember that we now have 2 independent variables. The first one is the age. So your age will take your beta 1. Your beta 1 in this case is what?
0.045.
Good. 0.045. That is your beta 1. Do we get it now?
Yes, sir.
Yes. Yeah.
Now, your beta 2 now is not the smoking status. Sorry, the next variable, which is independent variable, is the smoking status now, which is going to take beta 2 because we now have your x2. Your x1 is the age. That's why we're having beta 1. Your x2 now is not the smoking status. That is going to have a beta 2. Let's say we have another variable called x3. We're going to have beta 3. Now, what is your what? Your beta 2 now?
Minus 0.584.
Good. Great. I've not even shown you the answer, but you are getting the answer already. Now, the first question that they ask is that they ask them to write out the regression equation out. Remember that I showed you how to write out your normal equation. From here, look at this first equation. I have my y is equals to beta naught plus beta 1 plus x plus error. Now, since you have been, they've given us the beta naught, which is the intercept, and we know our beta, we don't need error again. What you will now write out now is not the predictive model, which is going to be like this. Now, the y here is your what from the question? The y is called what? What are our dependent variable?
Phenacetin.
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 Yes. So now, if you want to write out the equation now, that's the first question. Please, let's move to our mind. That's the first question. Your Y will not be phenacetin or plasma phenacetin is equals to what is your beta naught that you mentioned here? You will write it plus your beta 1 is what? 0.04. Then your X will be H, not X again now. It's going to be H. Then what is your beta 2? Your beta 2 is minus. Now, instead of you to write plus, now remember that you have minus. Minus times plus, it will give you minus. So you are going to have minus. Your beta 2 value is 0.584. Then what is now your X2? Smoking status. Let me take it again. Write out your regression equation. That's the first question, and it is 3 marks. So you don't need to crack any formula. You don't need to cram any formula. Go back to your linear regression equation. Your Y that you want to write out. Anytime they ask you write out the regression equation and you have all this value, it's no longer normal your regression equation that you have with error, but it is now your your model that you want to use to predict. Now, your Y at is the what? Is this phenacetin. Your beta naught is your constant when you are having a minus 0.064. Then your beta 1 is, because your beta 1 here is positive, so plus times plus is still retain plus. So we have 0.045. Then your X1 now is now your age. You will write age. Good. Your beta 2 is minus 0.58, but minus times plus is going to give you minus. So we're going to have minus 0.584. Then your X2 is the smoking status. Can you write out the equation now? Do you
Please,
have the equation?
Guys, please take it again, though.
Sir, please
should
take
take
it
it
one more
again.
time, please, sir. Yes, sir. We are
Yeah,
a
we
bit
can put
faster.
the beta
Okay,
two
let me take
now. We
it.
don't have to.
I want you to. Hello, one else.
Can you
Please,
take
let's
it
mute our
again?
mic. Let's mute our mic. Let's mute our mic. Now, I have the equation already, but I don't want to show us. I want you to get it so that you will not assume that you know it. Look at this question. The following is a data printout of regressing phenacetin on age and cigarette status. Now, they are regressing this phenacetin, which is our dependent variable. They normally regress dependent on independent. Please note that. They normally regress dependent on independent. Okay, so they normally regress dependent on independent. So now, in this case, our dependent variable is phenacetin. Then our independent variable is age and cigarette smoking. Then we have two independent variables. So this particular question is under multiple linear regression. We call it simple linear regression. Do we get that concept?
Sir, please.
Of this
Sir,
one is multiple linear regression.
Sir, did you say that age is a dependent variable?
It's independent. It's independent.
Okay, independent. Okay, sir.
It's independent.
Okay, age
Yes.
and
So do
smoking
you not?
status.
Yes, they are independent.
Thank you, sir.
So do you now know the reason why we are calling this multiple linear regression now?
Yes, sir.
Yes, sir.
I want other to answer. Do you now
Yes, sir.
know the reason why we are
Yes,
calling
sir.
it multiple
Yes, sir.
regression now?
Yes,
Okay.
sir.
Okay.
Yes, sir.
Good. Good.
Yes, sir.
Now let us now check the table. Look at this table. We have the phenacetin level. We have age, smoking status, and smoker. The reason why if you check their own too, they didn't put anything on that smoking status. So their own concern is that those people that smoke, that is the smoker. Now look at this. We have age, we have smoker. Then constant. CONS means constant, which is the same thing as your beta naught, which is the same thing as your intercept. Please get that. Constant is the same thing as your intercept, is the same thing as your beta naught. Let's go back to that question again. Now, we have our beta naught. Please, you can be writing it out like that. Your dependent variable, write it out to be plasma phenacetin is equals to your beta naught from this is the constant, from this what? From this table, which is minus 0.064. Remember that we always have plus here. Plus, check your first one, your independent variable for the first one is the age. So what is the beta 1 for age? 0.045 times, you will write age times age. The next thing is supposed to be plus because we are moving to the second independent variable. But immediately we check our coefficient, which is beta 2, is minus. So minus times plus, we're supposed to have plus, but minus times plus will be minus. So it will change it to minus 0.584 times smoking status. Do we get that, please?
No, sir.
Yes, sir.
No, sir. No, sir, I didn't get it.
Okay.
Sir, please, I didn't get it.
Sir,
You were mentioning
okay.
times. I don't know which of the equations, sir. So I don't know which of the equation you are talking about because we have a
Okay,
lot of
let me
equation
show you. Let me show you. Look at this equation 7. The beta 1 that you are seeing there is beta 1 times x. That's why they are writing it together. So if I say 0.05 h now, you may be asking me, how do we get that? That is 0. Whatever times the variable. Instead of now putting x is now representing h
which
for
is
the x1.
0.045.
The beta 1 now is now 0.05 or whatever that we have there, multiplied by h. But you can write it as 0. You can write it as was 0.045 h. You can write it like that, or you write 0.045 times h. It's still welcome. Now, let's go back to this equation again. Let's say I want to include one more independent variable. So I'm going to have plus beta 2 x2. I'm going to call this first one x1 plus beta 2 x2. Now, what is my beta 2? Come back here. Your beta 2 is minus 0.584. If I bring it down here, it's going to multiply the plus that I'm having to change it to negative. So now beta 2, now I'm going to have plus, instead of plus, I'm going to have minus 0.584 times, or you put minus 0.584 smoking status. So by the time you do that, you just earn yourself a good 3 marks for writing that the regression equation out. Let us now see it. Look at the first question. Write out the regression equation, which is 3 marks. Look at my solution. Phenacetin is equals to minus 0.064 plus 0.45H, then minus 0.584 smoke. You see that you are smoke. If it is smoker, it's going to be 1. If it is non-smoker, it's going to be 0. Remember that it's either someone is a smoker or not. So if it is a smoker, it's going to be 1. If it is non-smoker, it's going to be 0. So by the time it is non-smoker, if you put 0 here, everything here will be 0. So that means that we're going to have this. But if it is smoker, you put 1 here, we're going to have this. Do we get this equation now? Please get the first one now before we now move to the next question. The first one, is it clear? Write out the
Please, can you
regression
come
equation.
again, sir?
Sir, please
Come
explain.
again.
Can you
Explain again, sir. Thank you.
the smokers?
Which one should we explain again so that I can know?
The part you said that if
Solution
it is a
where you have
smoker,
phenacetin is equal to
yeah,
minus 0.64. Then where you are talking
plus.
about smoker 01 or something of such.
Okay. Look at the smoker status. Let me go back to the question. Now, look at this question. Regress on age and smoking and cigarette smoking. So that means that they are after those people that smoke cigarettes. So their own aim here, their own success here are those people smoking cigarettes. So anybody that is not smoking cigarettes is the failure. That is zero. So that their own objective here is those people that smoke cigarettes. So, and then we know that the cigarette status is either smoke or not smoke. So smoking is 1 and not smoking is 0. So now smoking that is 1 now, which is their target, and then not smoking will be 0. So is either we have 1 or we have 0. Now let us now go back to the table. Now the table given here are for smoker. Can you see smoker? So their objective is for those people that smoke. They are smoker. Are we together? So now
Yes, sir.
writing out this equation now, we have the phenacetin is equals to minus 0.64, which is the intercept constant from here, plus the H coefficient 0.045 H. Then I'm supposed to have plus, but remember that I'm having minus here. Minus times plus will give him minus. That's why I'm having minus here. Then 0.584 smoke, or you can put smoker. So now the reason why I'm putting smoke is that if this person did not smoke, instead of having smoke here, we are going to have 0. Let's say, for instance, I'm given the age. Okay, predict the phenacetin level. Please, you will do that for me now. Predict the phenacetin level of age 20, such that that person is a smoker. That person is a smoker means that anywhere you are seeing this smoke, you are going to put 1. Then age what? Age 20. Can you get me the phenacetin level? Can you do that, please? What is the based on this regression equation that we have? We now have a model that we can use to predict someone phenacetin level of age 20, and that person is a smoker. What do we have? Can you put pen on paper and predict for me?
I think it's 0.252.
0.252.
0.252.
By now,
0.252, sir.
0.252.
Yes,
that is
sir.
how we normally. That is how we normally predict. So you can now predict now based on this model. Now that's 0. What do you get?
0.252.
0.252.
That 0.252 that you've gotten now is now your y hat. Did you not get
Sorry,
it now?
please, how did you get that 0.252?
Please, can someone explain that, please?
You multiply
Okay.
20 by
You multiply 0.0.
and you just substitute with other number.
Our age is 20,
Our age here is 20.
which is a coefficient of 0.045, while our smoker value is 1, because the person is smoking, so it's 1. But if he's not smoking, it's 0. So when you multiply 0.584 by 1, you will have minus 0.584. Remember, the minus is a coefficient, is part of the 0.584, while our age is 20. Multiply the 20 by 0.045, and you will have 0.9. Then you now do the arithmetic. Minus 0.064 plus 0.9, which is the product of 0.045 and the age 20, then minus 0.584, which is a product of minus 0.584 times 1. So when you do the arithmetic, you now have 0.252. Thank you.
Thank you.
Do you understand now, ma?
Yes, sir.
The reason why I said someone should explain is that I want to know whether that person that is explaining really know what he's saying, and it's very, very correct. So that is how we
Thank
normally
you, sir.
predict.
Thank you, sir.
Now, that value that you just predicted is now your y at. So now, it's now your what? Your y at of the regression. So, do we understand that now before we move to the next one?
Yes, sir.
Good. So those are the bonus questions that people they don't even know it. So that's why they can't do it. It's a bonus. Or are you cramming any formula now? No. Just write out what you see. Let's look at the second one. Comment on the significance of each of the estimated parameter and interpret. Each of the estimated parameter. When you are talking about estimated parameter, these are the coefficients that they want you to talk about. And then anytime they ask you to talk, this particular question that you are seeing is 6 marks. So that means that how many variables that I'm having here? I'm having like 3 or 4. 3 variables. Oh, sorry, 3 coefficients I'm having here. That means that you have to say something about each of them. Look at this coefficient now. Look at your p-value. Look at the confidence interval. What can you say? Is H significant or not? Are we still
It
on the
should
same
be
page?
significant. It should be
Not it
significant.
should be. Not it should be. By now, it should be certain
Okay,
because
it
we've
is
treated test
significant
paper.
based on the
Age is
95% confidence
significant.
interval. It doesn't cross zero, and there is no negative. The lower and upper value
Okay.
has the same sign.
Okay. What can you say about the p-value?
The p-value, the coefficient is 0.04, which is less than the p-value. Okay, which is okay, it's greater than the p-value. So we do not reject or we reject which one?
Okay, that's why I'm asking you to say it. So please, if I ask question, please say it the way you know it so that I can know whether you get it or not. Do you get it now?
Okay, sir.
Now,
Value.
anytime I ask you to interpret the p-value, you come to the p-value, forget about the coefficient. Trace the coefficient to its p-value. Its p-value is 0.001, not the coefficient.
Okay, sir.
Take the p-value.
Okay, the
The
p-value is
p-value is
0.01, so it's of 0.05. So we'll
Okay.
reject the null hypothesis. We'll reject
Okay.
the null hypothesis.
Okay. Then when you reject, that means is what?
That means significant.
That means
If
age
anything,
is significant to the phenacetin level. You have to complete it so that you can get your mark. Age is significant to the outcome of phenacetin level. Do we get that, please?
Okay.
It's very important. Now, if you look at your p-value and confidence interval, they are saying the same thing. No contradiction. Please check the two. Are they saying the same thing?
yes.
Are they making the same decision?
Yes, sir.
Are they making the same decision?
Yes, sir.
yes,
I want
sir. They
another
are
person
making
to answer me.
yes, sir. They are making the same decision, sir.
Good. So you first of all interpret your coefficient.
Mhm.
How will you interpret the coefficient? The
Sir,
first
the
thing is
coefficient is 0.045,
okay.
and that coefficient is less than 0.05.
Okay.
When we take 0.05 as the decision, as the significant level.
Okay.
But for the 95% confidence interval, it's also less than 0.05 because the 5% shows is the margin of is the chance, 5% chance of error that we are looking at. And this one is less than 0.052. So the p-value and the 95% confidence are predicting the same thing because are saying the same thing because both values are less than the significant level of 0.05 that we have chosen as our significant level.
Another thing about
Okay.
confidence
Let me
interval, since
by
confidence, okay.
okay say something here. As at now, by now, I can boast that our knowledge about the p-value and confidence interval interpretation is 98%. Yes, and I'm happy with that. Now, but let me now say something about the coefficient. Coefficient has its own interpretation separately from p-value and confidence interval. Let me quickly show you the equation and then we'll interpret it together. Now, if you look at this equation, if I want to interpret the coefficient of this, a unit increase, if I increase a unit of age, first thing, look at the relationship between phenacetin and the age. The relationship is direct, that is, they are positive. Are we together now? It's positive relationship. Let me put it like that so that we can understand. It's a positive relationship. But the phenacetin and smoker, is a negative relationship. Please note that. If you want to interpret coefficient, this is how we normally interpret it. Now, the first one I'm taking 0.05. It's going to be a unit increase in age will lead to 0.045 increase in phenacetin, provided that all other variables are kept constant. Let me take that again. I'm taking age first. A unit increase in age will lead to 0.045 increase in phenacetin, provided that all other variables are kept constant. So after you first of all interpret that coefficient, then you can now move down to your p-value and your confidence interval so that you don't miss any marks. Can someone interpret the coefficient for smoking based on what I just said now?
That means a decrease of that means hello.
I'm with you. Say it.
Okay, I can't see the slide. Okay, the smoker. That means
Please say it.
a unit of decrease when there is decrease of 0.584 of phenacetin, there is that the smoke
The slide is not showing, sir.
It's showing. I can see
Is the
it, but
slide
I just
showing?
try to get it. The phenacetin will
Table
be
is not
increased to a
showing, sir.
unit of 0.584 as per smoker. I don't know.
Excuse me, I think we have to use the table to tell us to to explain the
What we are trying
confidence
to
part.
interpret here, what we are trying to interpret here is not the confidence interval, is not the p-value. We are interpreting the coefficient, and you can interpret it from
It's
the
not
model.
showing, sir.
We
Is it
can
not
see it.
showing?
I can see it.
The
It's
table is
Hey,
not
showing.
man,
showing.
mommy is network. It's not
Okay,
the
sir.
table I'm talking about. I'm talking about the model. We now have the model to be phenacetin is equals to minus 0.064 plus 0.045 age minus 0.484 smoke. Please let's mute our mic. Now, if I want to interpret the coefficient for age, it's going to be a unit increase in age. Please listen to it. You will be the one to interpret the second one. You must get the interpretation before we leave here. A unit increase in age will lead to 0.045 increase in phenacetin. The reason why I'm using the word increase in phenacetin because it is positive. Assuming it is negative, it's going to be decrease in phenacetin, provided that all other variable like this coefficient, the constant, the intercept, and then the smoking, whatever are kept constant. Let me take that one again. A unit increase in age will lead to 0.045 increase in phenacetin, provided that all other variables are kept constant. So please interpret the second one.
Okay, let me try.
Okay, sir, let me try.
Increase in smoker will lead to decrease of 0.58 of phenacetin, keeping other variable constant.
Okay, let me also try.
Okay.
In line with that,
Please try.
we can set a unit decrease in smoking will lead to 0.584 decrease in that should be increase, in phenacetin level.
Okay. Any other one?
Sir,
Please say something. No, everybody must.
a unit, sir, a unit decrease in smoking status will lead to a unit decrease in a unit decrease in 0.584 of smoking status will lead to a unit decrease in phenacetin level.
May I try?
Sir, can I try? Can I try, sir?
Please,
Sir.
everybody will try. We are one by one.
A unit decrease in the smoking level will lead to a unit decrease in the phenacetin level.
Okay, I want to
Another
try.
person.
Okay, a unit increase in smoking level will lead to 0.584 decrease in phenacetin level in the smokers, provided that all other variables are constant.
Okay, another person.
A unit increase in age level, in smoking level or status of 0.584 will lead to increase in phenacetin level when other factors are equal, are constant.
Another person, please.
A unit decrease in smoking status will lead to 0.584 decrease in phenacetin, provided that all other variables are kept constant.
Okay. Another person, please.
A unit decrease in smoking status leads to 0.584 decrease in phenacetin level, provided all of
So what if we say
Another person, please. At least we have
a unit
A unit
one by
increase.
one.
Okay.
Omotayo, can you go on?
okay, a unit decrease in smoking level
After Omotayo, okay.
will lead to 0.584 increase in phenacetin level.
Okay. A unit increase in smoking level will lead to a decrease in the phenacetin level. A unit increase will lead to 0.54, 584 decrease in phenacetin level, provided all other constants. All other parameters are constant.
Okay. Can we have one more before I conclude?
A unit increase in smoking level will lead to 0.584 decrease in phenacetin, provided other parameters remain constant.
Okay. Now, we have all tried. Honestly, I really commend the courage and then the effort. But nonetheless, let me quickly add this. Anytime you want to interpret a model, always use the word increase unit. Always use the word whether the model, whether the coefficient is negative or the coefficient is positive. The positive and negative, they only affect the dependent. Like now, a unit increase in smoking status will lead to 0.584 decrease in phenacetin level, provided that all other variables are kept constant. Let me take that again. A unit increase in smoking level or smoking status will lead to 0.584 decrease because of this minus. You know, when we are talking about the age, we say increase, but now decrease in what? In phenacetin level, provided that all other variables are kept constant. So I'm happy now that we can interpret the model. Okay, let me quickly.
There be a case where we have a unit decrease.
Sir,
have
I
a unit
think you said,
decrease.
sir, you said a unit increase in smoking status. Is
Yes.
it right?
Yes. Yes, sir. Because
So-
we are considering smoking status. So if I
So
increase the smoking status of this guy to be 2, I'm going to have 2 multiplied by this. Then it is going to be negative.
What effect will it have on the phenacetin
Promises,
level,
can you
sir?
hear me?
I can hear you, sir,
It will
loud and clear, sir.
decrease. It will decrease.
Okay,
It
when
will decrease. It
okay,
will
when
decrease. It will decrease.
okay.
Hello, can
Okay,
you hear
sir.
me?
I can hear you, sir.
So a unit increase in smoking status will lead to 0.584 decrease in phenacetin level, provided that all other variables are kept constant. Did you get that?
Thank you, sir.
Yes,
Okay.
sir.
Let me go rush
Question,
through
sir.
what I have here.
Sorry, in case that of the age, in case the result we have from the table is minus, and since we have plus, which can have minus times plus, we will give you minus.
Yes.
So that means if you want to interpret, we now say a unit increase in age will now lead to 0.4045 decrease in phenacetin level. Am I right?
Yes. Yes. Provided that you don't complete your
All
statement.
other, yes, are constant.
Constant. So when we are marking this, anytime we are given to mark, aside from what you are given as a guide, if any other person writes something that is relatable or statistically correct, or the interpretation is right, we cannot put all the interpretation in the marking guide. So that is one of the things that we also mark. Number 1, each of these parameters correspond to an amount of change in the level of phenacetin metabolism, which is right. Each of these parameters that we have, they contribute, whether decrease or increase, they contribute. Why the age was significant factor of phenacetin metabolism, smoking status was not. Look at this. Why the age was significant factor of the phenacetin metabolism, smoking status was not significant at alpha level of, at 5% level of significance. What did I mean by that? Look at this. Look at the significance of the smoking status. Look at the p-value. The p-value is greater than what? Is greater than the 0.05. That makes this one not significant. Look at the confidence interval. They don't have the same sign. That means that it crosses 0. That makes it not what? Not significant. Do you now understand the statement that I have for the number 1?
Yes, sir.
No, sir.
You
No, sir. I
understand that
didn't get
statement?
it. I didn't understand, sir.
Look at the statement. Each of these parameters correspond to an amount of change in the level of metabolism. That is, they contribute, whether negatively or positively, they contribute. Right? Yes. Now, I'm not taking age. Now, look at that age. Why age was a significant factor? The reason why I say age was a significant factor, look at this. The p-value of age is less than 0.05. That makes the age significant. And then the confidence interval does not include 0, or they have the same sign. So that means that it is significant. So age is significant. Now, look at the smoking status. 0.111 is not significant because this is greater than 0.05. And then if you check the sign, they don't have the same sign. So this make it not significant. Do we get it now?
Yes,
Yes,
sir.
sir.
Okay, now look at it. Why age was a significant factor of phenacetin metabolism, smoking status was not significant at alpha, at what? At 5% level of significance. So you can interpret in this way. Then you can also interpret as the spirit leads, provided that it is statistically correct. Now, look at the, oh, sorry. Where's my screen? Sorry, I mistakenly pressed off. Oh, sorry. Can you still hear me, please?
Yeah, we can hear you,
Yes,
sir.
we are hearing you.
Yes, sir. We can
When
hear
I
you,
was
sir.
trying to move my mouse, I mistakenly pressed off for my sharing of screen. Okay. Share the screen. Okay. Can you see my screen now?
Yes, sir. We can see it, sir.
Okay, thank you. Let me quickly put it
Sir,
in.
you need to put it in slideshow.
Yes. Okay. View. Okay. Can you see it now?
Yes, sir. Perfect, sir.
Please,
We
can you
can
see
see it,
it?
sir.
Okay.
Yes,
Okay.
sir.
Okay.
Yes, sir.
Sorry for that. Now, the next one is I took the, what's it called? I started from the negative minus 0.64, which is sorry, I started from the intercept rather, minus 0.64. On average, phenacity level is 0.0 what? 0.64 for a non-smoker at age equals to 0. Do you understand what I mean by that?
No.
Yes, sir.
Okay, let me explain.
No, sir.
Let
No,
me
sir.
explain it. Now, if my age is equals to 0, you know everything here will be 0.
Yes,
Am
sir.
I right?
Yes, sir.
Good. If it is for
Yes, sir.
non-smoker, I'm going to have 0 here. Right?
Yes, sir. Yes, sir.
So everything here too will be 0, right?
Yes, sir.
So I will left with what?
You left with
Minus
0.04 minus
0.064.
0.064 plus
Good.
0.045H. Yes.
No, when you multiply 0,
No,
age is not
you
0.
remain with
0
only the
multiplied by
minus.
this will be
Okay,
it
0.
will be minus 0.064.
If age is
Uh-huh.
if age is 0, it will be minus 0.0. It will remain minus
Yes,
0.064, sir.
yes. So that is what I mean by this. Look at this. Minus 0.064 on average. Phenacity level is 0 is what? Is 0.064. That is, if I'm having this on average, automatically phenacity level will be this on this condition for a non-smoker. For a non-smoker, that means that the smoking status here is 0. Everything here will be 0. At age 0, if I put 0 here, this will be 0. So this statement can only occur when we have non-smoker at age 0. Did you get it now?
Yes, sir.
Yes, sir. Yes, sir. Perfect.
Okay.
Yes, sir.
Now we are moving to the next one now. Look at this one. 0.064, sorry, 0.045 for each additional year of age, which is what I mean by any unit increase in age. So that's why I say you can follow your English or use any terminology. Just make sure that it is statistically right. Now, phenacetin level increased by this, while smoking status is held constant. You can write it like this too. Can you see it? Do you understand that statement?
Yes, yes, I do, sir.
No, I
Can
don't.
you hear me?
I don't, sir.
Yes, sir.
Please, can you come again?
I
No, sir,
understand,
we
sir.
don't. We
Okay,
don't
let me take
understand,
it
sir.
again. Now I'm moving to the next one now, which is coefficient for age. 0.045, which is the coefficient of age for each additional year, additional year of age, which is the same thing as any unit increase in age. Phenacetin level will increase. That's what I said. A unit increase in age, a unit increase in age will lead to 0.045 increase. That is the same statement here. Phenacetin level will increase by 0.04. A unit increase in age will lead to 0.04 increase in phenacetin level. Why smoking status is held constant? Because this one has already been defined as constant already. That's why the smoking status too can be held constant. That is the same thing as a unit increase in age will lead to 0.045 increase in phenacetin level, provided that all other variables are kept constant. It's still the same thing with this number 3.
Okay, understand.
Do we get that now?
Yes, thank you.
Yes, sir.
Do we get this now?
Yes, sir.
Okay. Okay.
So I have a question.
You said, please speak.
This slope, sorry, the
I
intercept.
can hear you. I can
For
hear
the
you, ma.
intercept, for the
Okay.
intercept. Can you hear
Okay,
me?
let's move on.
Hello? Can you hear me, sir?
I hear you. I'm hearing you, sir.
Okay, I said for
Yes,
the
I can.
intercept. Is there any interpretation for that intercept being negative instead of positive?
Is there any what?
Is there any interpretation for that intercept? That's our beta not being negative instead of
No. It's still
positive.
the same interpretation. When this one is equals to 0 point, please, you can mute your mic now. I get your question. You can mute your mic. When this one is 0.064, which is positive, it just be 0.064 on average. Phenacetin level is 0.064. Did you get it now? There is nothing like increase, there is nothing like decrease. It's just on average. Constant work on average. Did you get that now?
Okay.
Okay, let's move on. Can you still hear me, please?
Yes, sir. We can hear you, sir. Thank you,
Yes,
sir.
sir, we can hear you.
Okay. Now, lastly, now, number 4 now that I want to interpret, which is this smoking. Look at it now. Minus 0.584. If a particular smoker, the predicted phenacetin is 0.64, 0.584 lower. Do you see the word lower? Lower means that it is negative. Lower means that it is decrease. Remember that what we interpreted the other time is that a unit increase in this smoker will lead to 0.58 decrease. But you can also use the word lower. So look at it. Minus 0.584. If a particular smoker, the predicted phenacetin level is 0.584 lower than if we be for a non-smoker. If we be for non-smoker. Do you understand what they mean by that?
I think we are good with the
Yes,
first
sir. Yes, sir.
interpretation.
Non-smoker, yes.
Okay, you are good with the first
We are good with
interpretation.
the first
So
interpretation. Yes.
Sir,
okay,
sir, we
no
understand, sir.
problem. Now the
Non-smoker
last
is
question
0.
there. The last question there is just 3 marks, which we've done. That's the first thing I gave you to do. But I changed the age to be 20. Look at this. What is the predicted phenacetin metabolism level for age 40 who does not smoke? 3 marks. So it's just phenacetin level is equals to what? Minus 0.064 plus 0.045, 40. That the age is now 40 minus 0.584, which does not smoke. That is 0. So by the time you do the multiplication, I'm going to have minus 0.064 plus this multiplied by this will give me 1.8 minus everything here will turn to 0. Then we have 1.346, which is 1.45. So that is the result.
Thank you,
Then
sir. Question, sir.
when you do
Thank you,
this,
sir.
we've come to the end of that question. So now we've come to the end of EMS 727. By now, you should have a confidence that if you see any question in the exam, you'll be the one selecting the one that you want to do, not the question selecting you. You'll be the one to do what? To select the question. Please go over what we've taught. Then all the examples that we have in the slide, they are from past question, the previous past question. So please check the way we answer them. Check the way we answer the question. Mommy, please, can you mute your mic? Check the way we answer the question. Check the steps where they put marks. It's very, very important. If they ask you to calculate the mean and they assign 3 marks, it's not that you don't know the mean, but you may not get the full marks if you don't follow the procedure. Please, any question?
Question, sir.
Please go ahead.
Okay, concerning the B1, is it beta
Okay.
1 or I don't? So you know we are using the independent variable. We are using the age and smoker. That's why we say when it is smoker we use 1. If it is not smoker we use 0. In case we are giving other variables, are we going to range it like 1 and 0?
No, ma. It's because the smoker status is dichotomous. Let's say, for instance, you are given the weight. So that means that you must have the value. They will give you the value. Or predict the phenacetin level for age 40 with weight 60. So that means that you have a value for it. But it's because the smoking status is a nominal variable that have the 2 binary outcome, which is smoker or non-smoker. Do you get that, ma?
Okay, sir. Thank you.
Any other question? So because I have a lot of demand that they said they want physical, that they can't cope with online. So we have to come up with a physical class tomorrow. And that one is not going to be free. I told them. So I told them that one is not going to be free because we've tried and to do physical that is free. So that one is not going to free. And I charge those people that message me, I charge them, ask them to pay 2,450 naira. So we're going to be starting
tomorrow, sir.
Okay, we're going to be starting the class by 1 and we're going to finish by 5 or 5:30 so that we can brush up. Yes, sir. So that's because the first physical class that we had at UCH, due to the circumstances that are beyond my control, we are unable to use our 7 hours. We use 2.5 hours. So it's only the statistical inference that we touched, but we cannot finish the statistical inference. So I told them that if they want to join, tomorrow they are welcome, but they are going to pay that token. Now, for the UI own, we spend more than 7 hours, but we only treated descriptive statistics and inferential statistics. We didn't touch the probability and we did not touch correlation and regression. So tomorrow we are starting with the probability, then followed by correlation and regression, then followed by statistical inference. But we are not treating descriptive statistics tomorrow because discrete statistics has been well taught. So, and it is very easier to understand. So tomorrow we are going to be doing probability, followed by the correlation and regression, which we've taught tonight, and then followed by statistical inference. So by the time we finish that tomorrow, those people that will be attending that class tomorrow should be able to answer 5 questions correctly in the exam. But you that you've attended this online class now, you should be able to answer the whole 6 questions, but you will pick 4 that you know best, that will not waste your time, that you do not need to be cracking formula. Then you will solve it. So I wish you all success. Thank you so much. Any other question?
Thank you so much.
Thank you, sir. Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Hello, sir. Hello, sir.
Okay, thank you very much, sir.
I want to really appreciate you and also to inform you that the value we got from this your class is more than the money we paid. Seriously, it's more than the
So
money because when I inquired about 727 from our seniors, the way they painted it, I was like, God, how am I going to go? But, but ever since you brought up this idea and yeah, we subscribe to it, it has always been a light every day by day. It has demystified the cause, and we are no longer afraid of the cause. Thank you very much, sir. May God bless you for all you are doing for us in Jesus' name.
thank you.
Thank you, sir.
Thank you, sir. Okay, let me share my testimony with you. I was reviewing some research proposal and I dealt much on statistical aspect of it. If not because of this knowledge, I wouldn't have been able to do so. Thank you very much, sir. I'm very grateful.